SPMK Untar, and our speakers who join us virtually, Dr. Stephen Kidd from Australia, Dr. Gayatri Guru Rajan from India, and Professor Dr. Anshu Argawal from Saudi Arabia. And our moderator, Dr. Donatila Mano, SPMK. Good morning and best wishes always. Let me begin by giving you a warm welcome to the auditorium of the Faculty of Medicine of Universitas Tarumanagara for the international seminar with the theme Antibiotic Resistance, the Silent Pandemic. I'm Nikita Tan, a student at the Faculty of Medicine of Universitas Tarumanagara. I will be your master of ceremony for today's seminar. I would like to read for today's agenda. It will be opened by the opening, followed by welcoming speech and a group photo, and there will be seminar session 1 and 2, followed by breaks, and continued by seminar session 3, and the last one would be the closing. In order for the seminar to proceed smoothly, during the seminar, the audiences are asked to remain in the room until the seminar is over. Please keep all communication devices in silent mode. Participants who attend online are asked to keep their microphones in mute mode. Thank you. And now, we will be singing the Indonesian national anthem, Indonesia Raya, Mars Tarumanagara, and the medical faculty hymn. The audience is invited to stand.
Pemuda-pemudi semua, Universitas Tarumanagara, bersatu padu kita bersama, membela nama Tarumanagara. Hidup Tarumanagara, hiduplah, hiduplah selamanya. Hidup Tarumanagara, hiduplah, hiduplah selamanya.
The audience is allowed to seat. Next one, there will be a report on the seminar preparation activities that will be delivered by the chair of Shirley Gunawan SPFK. The floor is yours.
Good morning, ladies and gentlemen, all the students and lecturers. The Honorable Professor Dr. Insinyur Agustinus Purnairawan, MT, MM, IPU, ASEAN Inc., Rektor of Universitas Tarumanagara, Dr. Nur Sailan Tajudin, Spesialis Kedokteran Jiwa, Dean of the Faculty of Medicine, Fakultas Kedokteran Universitas Tarumanagara, Professor Dr. Lee Xiuyi, Dean of the Faculty of Health and Life Sciences, INTI International University, our distinguished speakers who has come to our campus, welcome to our campus, Professor Dr. Gita Subramaniam, Dr. Anis Karuniawati, PhD, Spesialis Microbiologi Klinik Konsultan, Ms. Lalita Ambigai Sivasamukam, Dr. Velma Herwanto, Spesialis Penyakit Dalam, PhD, Finasim FACP, and also our speakers who has joined virtually, Dr. Stephen Kitt, Dr. Gayatri Gururajan, Professor Dr. Ansu Agarwal, and also our lovely moderator, Dr. Donati Lamano, Spesialis Microbiologi Klinik. On behalf of the Seminar Committee on Antibiotic Resistance, we would like to warmly welcome all the participants attending our seminar today who have joined the Zoom application and YouTube live streaming, and also all the participants who have joined us in this auditorium. As we know, antibiotic resistance has become a major threat to global public health, the number of which continues to increase every year. In 2019, it is estimated that more than 1 million global deaths occur due to antibiotic resistance. And if it's not controlled, then by 2050, it is estimated the antimicrobial resistance, as known as AMR, will become the #1 killer in the world. In Indonesia, the challenge of antibiotic resistance is very real, with the increasing prevalence of antibiotic use and low awareness of the impact. That's why this condition is considered as a silent pandemic. Excessive and unwise use of antibiotics is one of the main causes of antibiotic resistance. Many patients in Indonesia take antibiotics without a prescription and for diseases that do not require antibiotics. Policies for monitoring antibiotic use are still weak, and public education about the dangers of antibiotic resistance still needs to be improved. So a multidisciplinary approach is urgently needed to overcome this problem. Today, the Faculty of Medicine, Universitas Tarumanagara collaborates with INTI International University, presenting the International Seminar on Antibiotic Resistance, the Silent Pandemic, and inviting speakers from several countries experience the same problems related to these conditions. The speakers will share opinions from various points of view. So this webinar will give us insight into the situation and opportunities to foster collaboration from multiple parties in sustainable efforts to overcome it. Thank you for the support from all the speakers, AMR Control Committee, Ministry of Health Republic Indonesia, INTI International University Malaysia, the University of Adelaide Australia, Vals Institute of Science, Technology and Advanced Studies India, Northern Border University Arar, Kingdom of Saudi Arabia, and also Faculty of Medicine, Universitas Tarumanagara. Special appreciation to Prof. Gita, who has initiated the idea of this seminar. Thank you so much. We extend our special thanks to the Tarumanagara Foundation, Director of Universitas Tarumanagara, Prof. Agustinus, our Dean of the Faculty of Medicine, Dr. Nur Sailan, who has supported this event so it can be realized today. We would like to express our gratitude to all participants. The total number of seminar participants registered today is nearly 1,500, with more than 900 registered in the Pelataran Sehat application. We really appreciate your participation in the seminar. We wish you a productive and enjoyable seminar and hope for a potential research collaboration with a promising impact on overcoming the problem of antibiotic resistance. Lastly, but certainly not least, we extend our heartfelt gratitude to all the committee of the seminars who have dedicated their time and also effort to meticulously prepare this seminar. Your hard work and commitment have been instrumental in making this event a reality. We acknowledge that there may have been some inconvenience in the organization of this seminar, and for what we apologize. However, we're confident that the collaborative spirit we have fostered with all our colleges will lead to a better life for all of us. Thank you.
Thank you to Dr. Shirley Gunawan, SPFK. Moving along, we'll have a welcoming speech from the Dean of the Faculty of Medicine, Universitas Tarumanagara. Please welcome Dr. Nur Selan Tajudin, SPKJ.
Okay, good morning to everyone here. To the Rector of Tarumanagara University, Professor Dr. Agustinus, and for the speaker, Professor Dr. Lee Xiao-yin, Dean of the Faculty of Health and Life Science, INTI, International University, Malaysia. Okay. Professor Dr. Geta from INTI, Malaysia too, thank you. Dr. Anis from Kemkes, terima kasih. And Miss Lalita Ambigai from INTI, Malaysia, thank you. Dr. Velma Herwanto, our lecturer, and there are three speakers joined virtually. Dr. Stephen Keane from the University of Adelaide, Australia, Dr. Gayatri Gurajan from Wells Institute of Science, Technology, Advanced Studies, India, and Professor Dr. Anso Agarwal from Northern Border University, Arar, Kingdom of Saudi Arabia. As well as honor guests and participants, I extend my warmest greetings to each of you. Yeah. First and foremost, let us express our gratitude to the Almighty for His blessing and guidance, allowing us to gather here today in good health and high spirits. It is a profound honor for me to stand among such esteemed company, including our distinguished international guests who have traveled from afar to join us for this important event. The seminar and workshop not only serve as a platform for learning, but also signify a meaningful collaboration between Tarumanagara University and INTI International University and colleges. To our guests and participants today, your presence exemplifies our shared dedication to confronting the silent yet profound threat of antibiotic resistance. Through robust dialogue and collaboration, we aim to deepen our understanding and explore innovative solutions to mitigate its impact. Together, we stand poised to shape a sustainable and resilient future for healthcare. I am confident that this event will spark insightful discussion, foster meaningful connection, and yield actionable outcomes. May our deliberations today generate fresh ideas, cultivate enduring partnership, and inspire collective action towards preserving the efficacy of antibiotic for generations to come. Last but not least, I thank you all for your presence and active participation. May this seminar and workshop serve as a beacon of knowledge, collaboration, and progress in our shared mission to combat antibiotic resistance. Thank you all.
Thank you to Dr. Nur Salan Tajudin, SPKJ. Next, we'll have a welcoming speech from the Dean of the Faculty of Health and Sciences of INTI International University, Professor Lee Shou-hee. To Professor Lee Shou-hee, the floor is yours.
Morning, everyone. Salam siang. It is my pleasure to welcome you all to this international seminar and workshop on antibiotic resistance. I would like to extend a warm welcome to our invited representatives from the government bodies, the Rector of Untar, the Dean, distinguished guests, esteemed speakers, and all participants. I would also like to express my sincere gratitude to the organizing committee for their dedication and hard work in putting this important event together. Antibiotic resistance is one of the most pressing health challenges of our time. The World Health Organization has classified it as one of the top 10 global public health threats facing humanity. The ability of bacteria to resist the effect of antibiotics has far-reaching implications for our healthcare system, economies, and the well-being of individuals worldwide. If left unaddressed, we risk returning to a time when minor infection could once again be deadly. So this seminar serves as a critical platform for us to come together to share knowledge, exchange ideas, and develop strategies to combat antibiotic resistance. Our collective efforts in research, education, and policy making are essential to tackling this issue. By collaborating across disciplines and borders, we can make significant strides in preserving the effectiveness of antibiotic for future generations. Throughout this conference, you will hear from leading experts in the field who will provide valuable insights into their latest research, trends, and solutions related to antibiotic resistance. So I encourage you all to actively participate in the discussion, ask questions, don't be shy, and share your experience together. In this case, we can build a stronger, more informed community dedicated to addressing this global threat. Thank you once again for being here and your commitment to this vital cause. I look forward to the productive discussion and innovative ideas that will emerge from this conference. Let us work together to ensure a healthier future for all. Let me close this speech with a pantun, Malay pantun. Ke laut pergi si nelayan, menangkap ikan di waktu pagi. Mari bersama kita lawan, agar generasi sehat berbakti. Thank you. Terima kasih.
Thank you to Professor Lee Shou-hee. Next, a welcoming speech continued with the opening of the seminar from our Rector of Universitas Tarumanagara, Professor Dr. Insinyur Agustinus Purna Irawan, MMMT IPU ASEAN Eng, that will be given through online speech.
Good morning, ladies and gentlemen. Welcome to Universitas Tarumanagara, a private university in Jakarta, Indonesia, established in 1959. As an excellent accredited university from National Board of Accreditation for Higher Education Indonesia, Untar has become one of the most leading Indonesian university with 8 faculties and 30 undergraduate, graduate, postgraduate, and professional programs with 15,000 students. Untar is driven by 3 core values: integrity, professionalism, and entrepreneurship. We educate our students based on these values to create entrepreneurial and professional leaders. Today, we are delighted to have of all the distinguished speaker and participant to join the international seminar hosted by Untar Faculty of Medicine and discuss more about antibiotic resistance, the silent pandemic that affect people worldwide. By the end of this seminar, I hope that we could focus on tackling this issue together. Doctors, policymakers, researchers, and all of us need to work together to use antibiotic wisely, find new treatment, and prevent infection. In this opportunity, I would like sincerely thank our dear friends from Malaysia, Australia, India, Saudi Arabia that willingly share their knowledge. We are looking forward to the next collaboration in the next future in both academic and non-academic, such as student exchange, lecturer exchange, joint research, internship, and other joint programs that could be developed for the improvement of academic and reputation of our university. With this, I pronounce this seminar is officially begins. Thank you.
Thank you to Professor Insinyur Agustinus Purna Irawan, MMMP IPU ASEAN Eng. Now, we'll be having a photo session first. So to Dr. Nursalan Tajuddin, the speakers, moderator, and the committee, please occupy the designated place. Please come forward. You may stand forward. So we will be facing the audience. Yes. The picture will be taken from the audience point of view. So the speakers, moderator, and Dr. Nursalan. Oh. Okay, maybe one more picture with the audience itself. Yes.
Oke, satu kali lagi video ya. Aku contohin. Untar untuk Indonesia, untar untuk dunia, untar selalu di hati. Oke, kita coba ya. Satu. Oh ya, salam untar. Oke. Oke, coba ya. Salam untar. Untar untuk Indonesia, untar untuk dunia, untar selalu di hati. Oke. Terus nanti diakhiri dengan tepuk tangan rame-rame. Oke. Oke, siap ya. Salam untar. Sekali lagi katanya. Sekali lagi yang kenceng ya. Salam untar. Untar untuk dunia. Untar untuk dunia. Untar selalu di hati. Oke, terima kasih. Silakan duduk kembali.
Okay. The agenda we all been waiting for. The first session of our seminar with the topics Understanding Antibiotics Resistance, a Global Outlook by Professor Dr. Gita Subramaniam, The Burden of Antimicrobial Resistance in Indonesia by Dr. Anis Kurniawati, PhD, SPMK Konsulen, and the seminar will be guided by our lovely moderator, Dr. Donatilla Mano, SPMK. But first, I'll read the CV of Dr. Donatilla. Dr. Donatilla Mano sebagai moderator kita pada pagi hari ini, untuk riwayat pendidikan beliau merupakan Fakultas Kedokteran Universitas Tarumanagara Jakarta pada tahun 2002 sampai 2007, kemudian profesi Dokter Fakultas Kedokteran Universitas Tarumanagara Jakarta pada tahun 2007 sampai 2009, dan beliau merupakan PPDS Microbiologi Klinik FKUI pada tahun 2015 sampai 2019. Untuk riwayat pekerjaan beliau, pada tahun Januari 2010 sampai saat ini, beliau merupakan dosen tetap FK Untar. Januari 2021 sampai saat ini, beliau merupakan dokter mikrobiologi klinik di Laboratorium RS Mitra Keluarga Gading Serpong. Pada Maret 2021 sampai saat ini, beliau merupakan dokter penanggung jawab Laboratorium BSL2 RSU Adiaka. Pada Januari 2022 sampai saat ini, beliau merupakan Kepala Bagian Mikrobiologi FK Untar. Untuk workshop beliau, ada banyak workshopnya, dan yang paling terakhir adalah workshop untuk penetapan multi-internal laboratorium mikrobiologi klinik pada tanggal 18 sampai 19 Februari 2023. I would like you all to welcome Dr. Donatilla Mano, SPMK.
Good morning, everyone. Welcome to our seminar on antibiotic resistance, the silent pandemic. My name is Dr. Donna, and I'll be your moderator today. We are thrilled to have you to join us this important discussion on a topic that affects global health. Before we begin, I'd like to go over a few housekeeping items. This seminar is being recorded. All attendees are muted. We encourage you to use the G form to submit your question at any time. We will address as many questions as possible during the Q&A session at the end of every session. Now, I am pleased to introduce our expert from the first session, Prof. Dr. Gita Subramaniam from INTI International University and College Malaysia will present the topic about understanding antibiotic resistance, a global outlook. And the second is Dr. Anis Kurniawati, PhD, SPMK, from Faculty of Medicine, Universitas Indonesia, MR Control Committee, Ministry of Health, will bring the topic about the burden of antimicrobial resistance in Indonesia. Each speaker will have approximately 30 minutes to present, followed by Q&A session at the end of this session. Our first speaker, Prof. Gita, who is born in Johor Bahru. Can you please? Yes. accomplished and energetic educator, currently in a leadership role and involved in curriculum development. Graduated from Bachelor of Science, University of Malaya on 1988 and graduated from Doctor of Philosophy from University of Malaya on 1994. During so many research on microbiology and antibiotic, last career as a Dean of FHLS International University, and now as interim Pro-Vice Chancellor of Academic Operation from 2023. Okay, now the floor is yours.
Thank you very much, and good morning, ladies and gentlemen. It's wonderful to be here today. I'd like to extend my deepest gratitude to Dr. Shirley for initiating this, which is a very important aspect of our global health today. So I'm going to give you a brief overview of the issue of antibiotic resistance from a global perspective. First slide, please. Next slide, please. Antibiotic resistance, well, the discovery of antibiotics. Antibiotics are actually very core components in medical therapy, as the doctors, future doctors and our current doctors can tell you. Very integral in the treatment of infectious diseases, which are rampant. So the discovery of one of the first antibiotics, penicillin, was actually a happy accident. Dr. Alexander Fleming went off on a holiday for the weekend and told his research assistant to clear up his plates. He was working with Staph aureus. When he came back, not only were the plates still there on his bench, but there were also fungal colonies growing, green fungus. So he was scolding his research assistant, and then he stopped when he realized around the fungus there was no bacterial growth. So something in the fungus actually could kill bacteria. And to cut a long story short, the discovery of penicillin. So penicillin helped to treat hundreds and thousands of soldiers, injured soldiers during the First World War, saved their lives. Otherwise, they would have died of simple infections. Next slide, please. So this is AMR in a nutshell, worldwide. Sorry, can I take this out? This is AMR in a nutshell, worldwide. So we have 14,000 people dying of Clostridium difficile infection annually, and the contributing factor, antibiotic misuse and antibiotic resistance. It's estimated that 23,000 patients die each year as a result of antibiotic-resistant infections in United States of America alone. Now, this data is from 2022, but I'm sure the numbers have increased till now. 400,000 infections per year with 6 most frequent multi-drug resistant bacteria in 4 types of infections in Europe. And it's estimated 25,000 patients die each year as a result of antibiotic resistance infections. 1 child is estimated to die every 9 minutes from infections caused by antibiotic-resistant bacteria. We'll ask Dr. Gayatri to confirm this later. And there are over 2 million infections per year that contain bacteria resistant to 1 or more infections. Now, this shows you that if we don't do something now, if we don't take a stand now, sooner or later we're going to end up in a situation where antibiotics are ineffective against treating any infectious diseases. And then what do we do, ladies and gentlemen? We've got nothing left. Right? Next slide, please. Thank you. Thank you so much. So WHO comes out with what they call Bacterial Priority Pathogen Lists, or BPPL, every year. And in 2024, the good news is MRSA was bumped down from critical priority to high priority. So currently, the 4 pathogens on the critical priority list, as reported by WHO, are Acinetobacter baumannii, Enterobacteriaceae to third generation cephalosporins, third generation, ladies and gentlemen. Enterobacteriaceae, carbapenem resistant, and Mycobacterium tuberculosis. Now, this includes rifampicin resistant Mycobacterium tuberculosis. On the high priority list, we've got Salmonella typhi, Shigella, Enterococcus faecium, Pseudomonas aeruginosa, non-typhoidal Salmonella, Neisseria gonorrhea, and there we have MRSA. So, critical priority, high priority. Sorry. Next slide, please. So the deaths from drug-resistant infections, as mentioned by Dr. Shirley earlier, are actually predicted to skyrocket in 2050. And the number of antimicrobial resistant infections are predicted to be equivalent to the deaths due to cancer, 10 million. This is just an estimation, ladies and gentlemen. Far more than deaths from diabetes, diarrheal diseases, even road traffic accidents. So we are heading towards a catastrophe unless we take a stand and do something about it. Next slide, please. Antibiotic resistance is more than a medical problem. It affects every facet of life. It is compounded by poverty. It is affected by universal health coverage, economic growth. With the downturn of economic growth, we have issues increasing antibiotic resistance. And of course, health inequity. This is a socio-economic and a gender-based factor. So effective antibiotics are actually a prerequisite for the successful achievement of many of the United Nations Global Sustainable Development Goals, the UN SDGs. And it's multidisciplinary. We assume that it was only to do with good health and well-being. But because it affects so many facets of life, socio-economic, etc., it actually covers a multitude of the 17 SDGs. Next slide, please. So what is antibiotic resistance? Before I go further, this is something you're probably familiar with, but let me just cover this. So it occurs when bacteria mutate and renders the current antibiotics used in therapy ineffective against the treatment of infections. And why does this happen? Due to prolonged use of antibiotics, eventually the bacteria will develop resistance. Now, this is true for any medication. If you take it on a long-term basis continuously, our body will develop resistance. The bacteria are no different. The sad fact of it is, it takes up to 10 years and billions of dollars for an antibiotic to be developed, discovered, created, and launched, marketed. But it takes less than 2 years for the bacteria to develop full-blown resistance to the antibiotic. So can you see the conundrum, the issue that the drug companies are facing? Why do they have to spend millions and millions of dollars developing something that's going to be ineffective in a few years' time when there's very little return of interest? Therein lies a problem for the rest of us. So using antibiotics when they are not needed, as mentioned by Dr. Shirley, is one of the reasons resulting in what we call selection pressure. And I'll show you that a little later. Next slide, please. So the main causes of antibiotic resistance are misuse and overuse of antibiotics. How many of you in the audience have been prescribed antibiotics for the common cold or for COVID? Anyone? I know I was. I didn't take it. All right? Common cold, COVID, these are viruses. Antibiotics are not effective against viruses. They do not work, right? You have antivirals for that. Now, antibiotics are one of the most commonly prescribed medication. Now, I've spoken to people, doctors, medical students in Uzbekistan, in Australia, in New Zealand, in India, even Indonesia, Malaysia. The problem that we have is that you can get antibiotics sold over the counter without a doctor's prescription. Ladies and gentlemen, this compounds the issue of antibiotic resistance. You are taking antibiotics without knowing whether they are the correct antibiotics, number one. Number two, whether you actually have already developed a resistance to that. Now, Dr. Anshu Agrawal this afternoon will be sharing some of the issues of misuse and overuse of antibiotics. So let's look forward to that. I won't step in on her presentation. So up to 50% of all antibiotics prescribed for people are A, not needed for viruses or the wrong antibiotic, or not taken correctly. How many of you don't finish your antibiotics because you feel better after 3 days when you're given a 5-day prescription? Don't be shy, we're not taking down your names or taking photographs. Okay, there are some of us, we feel better, okay, we don't want to take it, especially if we have reactions to the antibiotics, we get nauseated or we throw up. So of course we don't want to finish taking it. We feel better. Sorry to tell you that you're actually creating a situation where your bacteria are developing resistance, right? Okay, and finally, sorry, previous slide. Antibiotics are also unfortunately used in food for animals because A, to of course prevent, control, treat diseases in animals, but they found that antibiotics actually contributes to the growth of animals. So you have nice big fat cows and sheep, you know, and they are fed with antibiotics. They use them as growth factors. So you think that this is not so much of a problem. It is. If the meat is not cooked properly, we take it a little raw or undercooked, we are actually consuming the antibiotics and introducing them into our system. Or worse still, if it's passed through the feces of the animal, it remains as a reservoir in the environment. So again, we're helping to create antibiotic resistance in this way. So drug-resistant bacteria, as I mentioned, can remain on meat. And it's not handled or cooked properly, it will spread to humans. Next slide, please. So how does antibiotic resistance develop? Next slide. You're prescribed antibiotics, right? So you have a harmful colony of bacteria, but what you don't realize is a mutation could have happened to create an antibiotic-resistant cell. And then this antibiotic will create selection pressure, killing the non-resistant cells in green, but the resistant cell remains. So if you don't finish your antibiotics, what happens is this resistant cell will survive and proliferate, and thereby creating an antibiotic-resistant organism. Next slide, please. So these are the targets of antibiotics. Our scientists are very clever. They've developed antibiotics towards many different targets on the bacterial cell. So depending on the species of bacteria and the type of infection, you will have different antibiotics prescribed. You've got the beta-lactams and vancomycin, which attack the cell wall, destroy and degrade the cell wall of the bacteria. Fluoroquinolones and rifamycins will affect the DNA or RNA synthesis. Trimethoprim sulfonamides will affect the folate synthesis. Daptomycin also degrades the cell membrane. And finally, linezolid, tetracyclines, macrolides, aminoglycosides will affect protein synthesis, inhibit protein synthesis. So many different groups of antibiotics for different modes of action on the bacterial cell. This is good. This is bad. These are the resistant mechanisms that the bacteria have developed against the antibiotics that the companies have produced, that we are using. So they have efflux pumps. These efflux pumps, literally like their name, pump out the antibiotics from the cells before they can actually start affecting protein synthesis or DNA or RNA synthesis. All right? So they pump it out. This is very common, especially in Pseudomonas, Acinetobacter, and several other bacterial species. And then you have impermeability. They just make mutations in their cell wall, on their cell membrane, and it becomes impermeable. The antibiotics cannot go through the cell wall and cell membrane to enter the bacterial cell. So the tetracyclines, sulfonamides, and vancomycin, trimethoprim, these are affected by the impermeability. And then they also go as far as modifying their proteins, modifying their DNA and RNA, so that the antibiotics don't recognize them anymore. Because the antibiotics are designed towards certain parts of the protein or certain parts of the genome, the DNA or the RNA. So if the bacteria changes it, mutates, it becomes unrecognizable. Like you going out with a hat and dark glasses and a big overcoat, people won't recognize you. Similarly, it's kind of like a hat, glasses, and overcoat that the bacteria have done, all right? Target modification. So the fluoroquinolones, rifamycins, vancomycin, penicillins, macrolides, aminoglycosides, all these are rendered ineffective due to target modification. And then, who can forget the inactivating enzymes that are produced by the pathogens themselves? The beta-lactamases produced by the Enterobacteriaceae, aminoglycoside resistance, the macrolide inactivating enzymes, and the rifamycin inactivating enzymes. So for whatever we have to destroy the bacterial cell, the bacteria have developed resistance mechanisms. So it's just survival. They want to survive. And who lose? We lose, ladies and gentlemen. Next slide, please. So this is the consequence of antibiotic resistance. This is an isolate. You can see, we're going to do this in the workshop tomorrow. Diffusion, a very simple but crucial way of determining the resistance profile, or what antibiotics basically can, the susceptibility profile, let me say, for any infective pathogen. So in this plate, you can see this bacteria. There's a big zone of clearing around all the antibiotics, which means these antibiotics are effective in the treatment of this bacteria. The zone of clearing means the antibiotic cannot survive. Unfortunately, this is a resistant bacterial isolate. 4 of the antibiotics, no zone of clearing, absolutely resistant to the antibiotics. 2 are still effective, luckily, and this is what we call intermediary resistance. It is partially resistant, partially susceptible. Let's look at the cup half full, partially susceptible to this antibiotic. But I wouldn't use it, and I'm sure your doctors would not prescribe this one. We would go for these 2. Right? Next slide, please. So this is the development of antibiotics versus the deployment of antibiotics. They develop, we deploy. So in 1930, sulfonamides were actually released, and in 10 years later, they became there was resistance to sulfonamides. Penicillin, 1940s, and in 1946, the first resistant isolate to penicillin was detected. And it gets slower, closer, and closer. Here you have linezolid. Look at linezolid. 2000, and in 2003, already linezolid resistance. Daptomycin, under 2 years. So ladies and gentlemen, we can deploy, but they will develop resistance. Next slide, please. This is the frightening part. This timeline illustrates the drug companies' lack of development of antibiotics in what we call the antibiotics void. So following the commercial development of the first antibiotic in the 1950s to 1980s, there was a splurge of discovery from development of penicillin. There were lots of antibiotics discovered, as you can see. Beta-lactams, aminoglycosides, streptogramins, quinolones, macrolides, tetracyclines, so many. What about here? From 80s to 2010, hardly anything. So we call that the antibiotics void because, as I mentioned earlier, it takes more than 10 years to develop an effective antibiotic, but less than 2 years now for the bacteria to develop resistance. So the drug companies are actually asking, what is the point? They rather go for the more lucrative drugs. You can't blame them. They're investing a lot of money and time. They're going for the more lucrative drugs against cancer, against heart disease, against diabetes. These are more widely used, and they're used every day. So the return of interest is extremely high. But what are we going to do if there are no new antibiotics developed? That's what I hope my colleague, Ms. Lalita, will try and this is instilled in you in her session. Next slide, please. So what's the impact? We all know it's not good, but do you know how bad it is? When infections can no longer be treated by first-line antibiotics, we have to go through more expensive medications with more toxic side effects, like polymyxin B. We rarely use certain antibiotics. They're effective, but they have toxic side effects. They affect some of our organs. Our learned, your learned dean, Dr. Shirley, Dr. Donna, they can advise you on that. right? Longer duration of illness, we are not getting cured so easily. So the hospitalization stay is much longer. The patient is much more ill. And unfortunately, another problem with extended hospitalization stay is we pick up additional infections, nosocomial infections. And the most common among them, Klebsiella pneumoniae, Pseudomonas aeruginosa, Acinetobacter baumannii, just to name a few. And they are mainly antibiotic resistant as well. So you are there for one infection with one type of pathogen, resistant pathogen. You might end up with more than one. And serious, much more serious, leading to ICU stays. So increased illness, treatment, this will put a burden on healthcare costs and economic burden on families and societies, especially if it's a breadwinner who's infected and who's lying there hospitalized, unable to work. Who's going to support the family? If the mother is there, who's going to look after the children? So it's not just infection and treating it. It affects every aspect of life, ladies and gentlemen. Not only that, organ transplantation, chemotherapy and surgeries, even C-sections, appendix removal, these become more dangerous than routine surgeries as before without effective antibiotics to prevent and treat infections. So you could go for a simple surgery but pick up a very deadly infection. I say deadly because there might not be antibiotics to overcome this infection. Next slide, please. So 3 economic sector value chains actually very strongly influence both the development and spread of antimicrobial resistance. The first being pharmaceutical and other chemical manufacturing. Because if we don't have newer antibiotics being manufactured, we are running out of options for treatment. Agriculture and food, including animal production, aquaculture, food crops. As I mentioned earlier, not only are antibiotics used to treat ill animals or prevent disease, so they're giving them to perfectly healthy animals, they're also used as growth factors to help them grow, produce more meat. So this becomes a compounding factor as well. And finally, healthcare delivery. We use a wide range of chemicals and disinfectants in the hospitals. Of course, bacteria will eventually try to develop resistance against these chemicals. And sometimes a patient comes in very, very ill. If they are prescribed, I believe this does not happen in the government hospitals. I'm sure I speak for Indonesia as well as Malaysia because we do the culture and sensitivity to determine. But if the patient is extremely ill, they will prescribe empirical therapy before they get the CNS results, and more definitive therapy can be prescribed to save the patient's life. Next slide, please. So, as I mentioned earlier, we thought that antibiotic resistance was just affecting good health and well-being, which is SDG 3, the United Nations Sustainable Development Goal 3. But ladies and gentlemen, it's so much more. Next slide, please. As you can see, antimicrobial production actually affects zero hunger because the poor communities all over the world, they don't have access to healthcare, suitable healthcare. I'm not saying that we don't give them healthcare, but there's less easy access, right, to the very, very poor, the poverty-stricken regions around the world. So this enables the spread of the antimicrobial pathogens more easily. So they actually become the reservoir, they have higher mortality rates, and then of course with good health and well-being, definitely. What about this, number 6, clean water and sanitation. If you don't have clean water and sanitation, pathogens can spread to that, cholera, etc., right? And then you have responsible consumption, you have number 11, climate action. All these actually are linked and contribute towards the spread of antimicrobial resistance. Next slide, please. So these SDGs, in turn, next slide, will actually affect all the other SDGs, right? So as a consequence, the World Health Organization decided to work together with 3 other lead organizations, United Nations Food and Agriculture Organization, of the United Nations, FAO, UN Environmental Protection Program, UNEP, and the World Organization for Animal Health, WOAH. They joined forces as to advance international cooperation for one health response on antimicrobial resistance. So this was a huge step that the United Nations took because they realized antimicrobial resistance a few years ago was already one of the top 10 issues in healthcare as determined by WHO, and it wasn't improving. So they took a huge step and jointly developed a strategic framework for collaboration on AMR and how they could deliver the vision of the framework within the next few years. So in 2022, 2 years ago, they signed an agreement to strengthen this cooperation and fully integrate the environmental conditions into One Health efforts, including those that are related to antimicrobial resistance. And they also developed One Health Joint Plan of Action with antimicrobial resistance as one of the top 6 priorities. So this quadripartite consolidated their joint secretariat to lead and coordinate global efforts across the One Health spectrum by consolidating cooperation across the world. So kudos to UN and the other 3 organizations. Next slide, please. So what do we do? Ladies and gentlemen, each and every one of us can make a difference. We can do something to compound this problem. But what we should understand is the global consumption of antibiotics is in the billions worldwide, and it's increasing. It's consumed by humans and animals to modify the commensal microbial flora. If we are consuming antibiotics indiscriminately, this is going to affect our microbial flora, our normal flora, making them pathogenic organisms. Yes, they are microbial flora. They're normal flora, they are there to help us. But in the event that we are very ill, then they become opportunistic pathogens and we are infected with our own antimicrobial resistant pathogens. So the adaptive capacity of humans and animal pathogenic bacteria, why does this happen? Because of the genome plasticity within the bacteria that enables them to mutate and adapt. We expose them to antibiotics, yes, we kill some, others adapt, mutate, become resistant. Right, next slide please. Furthermore, antibiotics consumed by humans and animals, they are dispersed into the environment. And the resistant organisms that develop within the animals and humans are also dispersed into the organisms, giving an environment, a pool that's existing out there that we don't know about. So the environment becomes a natural reservoir, and permanent exchanges between human, animal, and environmental reservoirs will further perpetuate the emergence and spread of antimicrobial resistance. This is a global problem. It's not here, it's not there, it's everywhere. Hence, it is necessary to develop either new antibiotics or new antimicrobial agents, new therapeutic strategies, not only to combat antibiotic resistance, but to reduce the consumption of the current antibiotics in humans and animals that are not needed. I'm not telling you all when the doctor prescribes antibiotics, when you're really ill and need them, you say, no, I'm doing my bit for antimicrobial resistance. No, please don't do that. It's the indiscriminate use, the unnecessary use, and the lack of awareness that we don't finish our dosage. Next slide, please. Next slide, please. So these are the key facts from WHO. Number 1, antibiotic resistance is one of the biggest threats to global health, food security, and development. Antibiotic resistance can affect anyone, you, I, anyone, and any country. That's why it's a global issue. Antibiotic resistance occurs naturally, but unfortunately, when we misuse and abuse antibiotic usage, then it's going to compound, increase dramatically, which it is actually. And a growing number of infections like pneumonia, tuberculosis, gonorrhea, salmonellosis, they're becoming increasingly harder to treat because of antibiotic resistance. You give antibiotic A, not effective. You go to something stronger, B, not effective. You go to C, and eventually you will run out. So we are heading there, ladies and gentlemen. Not quite there yet, but we are heading there. And furthermore, antibiotic resistance, as I mentioned earlier, leads to longer hospitalization, higher medical costs, increased mortality. Next slide, please. So in conclusion, ladies and gentlemen, all I want to say is resistance to antibiotics is prevalent in bacteria because of their capacity to mutate and develop antibiotic-resistant mechanisms. And this causes serious infections in humans. It's increasing in certain types of bacteria, including the gram-negative pathogens, and the infections caused by these multi-drug-resistant pathogens. Multi-drug meaning resistant to more than one antibiotic, is associated with excess morbidity and mortality. And finally, they're also associated with substantial extra costs. Next slide. And that concludes my presentation for this morning. Thank you.
Presentation. Now, directly we call the second speaker, Dr. Anis Karuniawati, PhD SPMK, will talk about the burden of antimicrobial resistance in Indonesia. Oh, it's okay. The CV of Dr. Anis. Dr. Anis is doctor at Faculty Medicine of Universitas Indonesia, PhD in Bacteriology from Universität Hohenheim, Stuttgart, German, and Specialist Microbiology from Collegium Pamki on 2001. Now, since 1991, as dosen and peneliti FKUI, since 2009, anggota subkomite PPRA RSCM. Since 2018, Wakil Dekan FKUI Administrasi SDM Kerjasama Ventura and Alumni. Since 2021, Ketua KPRA Kemenkes. 2022 until 2025, Ketua Umum Pamki. 2022 until 2025, anggota Dewan Perhimpunan Dokter Spesialis dan Subspesialis Majelis Pengembangan Pelayanan Keprofesian. 2016 until 2025, Ketua Bidang Organisasi Pengurus Pusat Perdalin. 2021 until 2024, Wakil Ketua 2 Perhimpunan Gastroenterologi, Hepatologi, and Nutrisi Anak Indonesia. Dr. Anis, the floor is yours.
Ini kali. It is not yet, yeah. So thank you, Dr. Dona, for the introduction. Assalamualaikum warahmatullahi wabarakatuh. Good morning. So it is a very honor for me to be here as a teacher, as a lecturer, but also as a chair of the AMR Control Committee under Ministry of Health. It is a very good opportunity for me to introduce you about the problem of AMR in Indonesia. So Professor Gita has explained us very clearly about how important it is. Yeah. So Professor Gita has told us about this problem is not only in human sector but also in other sector. So that's why we, the government of Indonesia, has developed two national action plans. This is for the year of 2017 until 19, and the other one is, so it doesn't work, the laser doesn't work. So the other one is the National Action Plan from 2020 until this year, to 2024. And because of the multi-sector, this National Action Plan was developed together with all sectors involved in the AMR control. So for example, Ministry of Health, Ministry of Agriculture, Ministry of Maritime and Fishery, Ministry of Environment. Thank you. Yeah, so also Ministry of Education and Culture. Yeah, because it is also very important maybe to change the curricula in the school or also in the higher education. Yeah, so for this National Action Plan, it was not legally recognized, but here the new one, sorry, I cannot proceed the slide. Maybe ininya mesti ditempelin, Dok. Yeah, so for the new one, which is, sorry, the last one still, it is under the regulation of coordinating ministry in Indonesia, because this coordinating ministry will have the coverage to all the sectors or other ministry. So we have 6 strategic objectives. It is almost the same as the strategic objective already developed by the WHO. First is the raising awareness, second is to improving the scientific knowledge and evidence base through surveillance and research, 3 is the reducing incident of infection, 4 is optimizing, supervising, and enforcing follow-up sanctions against the distribution and use of non-standard antimicrobials in all sectors, and also increasing the research to develop the new diagnostic method, new drugs, and also new vaccines. And the 6 is actually very specific for Indonesia to develop the integrated governance and coordination to control antimicrobial resistance. So for the number 6, we have now the Interministerial Task Force Working Group for AMR Control, which is chaired by the DG of Health Services and Ministry of Health, and all the Secretary Working Group consists of all sectors. So sorry, it doesn't work, so please help me. Anyone? Yeah, so this is all the sectors that involve also the BRIN, the National Research and Innovation, also the BPOM, the Indonesian Food and Drug Administration involved in this National Action Plan. So next, so for this, the National Action Plan has this indicator and target. So please next. Yeah, this is the 4 indicator which also involve other sectors that we have already determined. For this, the target is in 2024 as showed here. For example, the percentage of ESBL production, ESBL reduction. So all ESBL or extended spectrum beta-lactamase producing Enterobacteriales should be, of course, reduced from, so actually this, in human, The baseline data in 2020 is 62%. Sorry, it is wrong. It is not correctly written. The target in 2024 is actually 52%, not 62%. But the achievement in last year is still 68. So this is actually due to the pandemic also. So there is no budget during the pandemic for AMR control in Indonesia. And also we know that the use of antibiotic during pandemic is very, very high. Yeah? And in the animals, it is not yet really defined how is the achievement for reducing the ESBL, but soon we will have it. In the environment, it is also very difficult to have representative data, but what we have now is actually from the Tricycle project and also some of study with different methodology approach. Yeah, so there are some study that detect the gene, the antimicrobial resistant genes in the environment, and the ASBL is only 2%, but actually it is, I think it is not the real data. Yeah. The percentage of qualified antimicrobial in circulation, this is good achieved. And then the third one, it is actually very important for you students here because you will be the new doctors in few hours and you will work in Puskesmas, in our primary health care. This is the target for primary health care. So there are two diseases, infection disease. First is the acute respiratory tract infection, non-pneumonia. So as Prof. Gita also explained, it actually doesn't need any antibiotic because more than 95% the etiology is viral infection. Yeah? So that's why in this acute respiratory tract infection, non-pneumonia, the use of antibiotic is targeted less than 20%, and for non-specific diarrhea is less than 8% in Puskesmas. So please remember it. So please don't use too much antibiotic for acute respiratory tract infection and pneumonia and for non-specific diarrhea. Yeah, and then also the fourth is the use of prophylactic antimicrobial in broiler chicken farms. The target is 50%, but still now the achievement is still 71%. Sorry. Okay, next. So Indonesia has also joined the global laboratory AMR surveillance system, which is conducted by WHO. Next slide, please. Next click. Yeah. So sorry, still the previous one. Yeah. So this is the GLASS. It's Global Laboratory Antimicrobial Surveillance System. So until 2022. We have 20 sites in Indonesia, but hopefully this year we will report the AMR surveillance from 81 hospitals, hopefully. So we are still ongoing to clean the data and then report it to GLASS. So this is the site where the data come from. And the next slide, please. Yeah, this is the result. So the trend is still increasing. For example, this is the resistant trend to the third cephalosporin for Escherichia coli and Klebsiella pneumoniae. Both are Enterobacteriales. Yeah, it is stagnant, but there is also a sign for increasing. This is the resistant trend for carbapenem. So the percentage is actually much less than the cephalosporin third generation, but because carbapenem is the reserve antibiotic, and this is actually the hope of all our intensivists in ICU is that carbapenem still have the high susceptibility, but in the reality, so for example, for Acinetobacter baumannii is much increasing the last year. And this is also the resistant trend for fluoroquinolone. So genetically, the bacteria or the gram-negative bacteria that are resistant to or producing ESBL, extended spectrum beta-lactamase, has also the potential to be resistant also to fluoroquinolone, yeah, because the genes are very close each to other. The place of the gene. And also this is the resistant trend of Staphylococcus aureus. So this is very low, maybe also due to the very low specimen, clinical specimen that are sent to the clinical microbiology laboratory. Next slide, please. The next is, this is the surveillance conducted by our organization profession. So I'm, as mentioned before by Dr. Donna, that I'm also the chairperson of the Association of Clinical Microbiology in Indonesia, and we contribute data also to the government. So through the collecting data collection from all this hospital, it was in 2022 from 71 hospital. So it is actually not really represent Indonesia, yeah, because for example in Lombok only one hospital, Kalimantan one hospital, Sulawesi and Papua also it's one hospital. But I think this is better than the one for glass, yeah. So next. So for this we focus, so this is the distribution, just next. So we collect the data from these three levels of hospitals, type A, type B, and type C. So we know that type A hospital is it can be professional referral hospital or regional referral hospital, and B is district hospital, and C is sub-district hospital. Yeah. So actually, it also depend on the number of beds. Next, please. And this is the type of specimen, so blood, urine, and from the lower respiratory tract. So it can be sputum or bronchoalveolar lavage. This is from the joint, cerebrospinal, pleura, ascites, and pericardium. And this is the number. So the C so contribute much less specimen compared to the type A hospital. Next, please. So we focus on the critical priority pathogen, which already explained also by Professor Gita. So there are some critical priority pathogen, which is the Enterobacterialis resistant to third generation, and also third generation cephalosporin, and also to carbapenem, and also other, for example, Pseudomonas aeruginosa, Acinetobacter baumannii, and the last one is the methicillin resistant Staphylococcus aureus. And this is from 2020 to 2022. So the MRSA has a tending to decrease, but again that it is also, it can be the real data, but also it is not the real data, because the decreasing number of clinical specimen which is sent to the laboratory. So next, please. The next one, I just want, yeah. So this is the data from 3 hospitals. So the blue one is from A, B, and C. I want to show you here that the critical pathogen is not only found in the provincial or regional referral hospital, but also in the sub-district hospital. So it means that actually the carbapenem, for example, which is actually the last resort antibiotic, is already used in that level, yeah, in sub-district hospital. So next, please. So so this is to show you for the each hospital, each type of hospital based on this specimen. I show you here the three important specimen because usually the prevalence of infectious disease in the hospital, which is inpatient hospital, is from blood, come from sepsis patient, and then pneumonia and urinary tract infection. Yeah. This is the type A. It is okay because the referral, yeah, usually all are critical patient. So next for the B, sometimes B is also provincial, yeah. Please, next slide, please. And the next slide is C. Yeah, so C, you see here that MRSA is also exists. The carbapenem resistant Acinetobacter baumannii also exists from these three important specimen. Yeah, so next please. Yeah, this, the distribution based on the province. So this is Jakarta, West Jakarta, Central of Java, East Java, Bali, and West Nusa Tenggara, Sulawesi, Kalimantan, Sumatra, and Papua. So maybe Papua, we know that only one hospital, also other place. Yeah? Bali and NTB is more than two. So please also, we have to be careful in interpreting the result here. So this is very important to this slide to show you that the existence of this resistant, very important critical priority pathogen has already spread in all islands. Yeah, not only in Java, but also in all islands. So it means that wherever you will be sent as internship doctors, then you have to implement the rational use of antibiotic. So next, please. Next slide, please. Yeah, so this is the systematic review that we produce. Yeah, so I'm one of the authors, and this is very new, so it published in this year. Next, please. Yeah, so this gives the more or the broader overview of the AMR problem in Indonesia, because this systematic review collect all the publication from 2020 until 23, and so there are also hospital-based and community-based, and also from different places of Indonesia. Next, please. This is the number, so this is only the number of the report, but this one show you the number of the isolate collected in this publication, in this journal. So this one, the black one, or actually this is very dark blue, is the number of isolate from the hospital, collected from the hospital, and the other one is collected from the community. So community-based and hospital-based. Next, please. And this is the result of the resistance. Yeah, so Klebsiella pneumoniae against this antibiotic, E. coli against this antibiotic. The dark one is from hospital, and the light one, the light color, is from the community. So of course it should be also interpret carefully with the colistin, because colistin antibiotic is not easy to be tested. Yeah, so maybe this report produced from the wrong methodology, yeah, because this time we still use semi-automatic method or diffusion, which is not reliable for colistin. Yeah, so maybe this is not good data for colistin. Yeah, so we can see here that the problem is actually also for the third generation cephalosporin very high, and fluoroquinolone, and against Klebsiella pneumoniae, and E. coli is almost the same. And the next slide, please. Yeah, this is for Pseudomonas aeruginosa. Yeah, also very high number of resistant. Acinetobacter baumannii also, and Streptococcus pneumoniae, again cotrimoxazole, penicillin, and also oxacillin and erythromycin. So it is actually very important for us to very careful in choosing all these antibiotics, because we know that macrolide like erythromycin, azithromycin, clarithromycin is used very much, yeah, in all kind of infections. Yeah, next please. So this is, I want to show you the Neisseria gonorrhoeae here. Yeah, this is very important because the right now the guideline to treat gonorrhea infection is clinical, based on clinical syndrome. So there is no obligation for the doctors to send the specimen in this, in gonorrhea usually we got from cervix, yeah, the swab of cervix or vaginal, yeah, and it is also very difficult to find it microscopically, so that's why it should be supported with the culture of Neisseria gonorrhoeae. And Neisseria gonorrhoeae is a fastidious bacteria, very difficult to grow, and that's why the WHO and also the Ministry of Health Indonesia decide to use clinical syndrome to treat and to give the antibiotic. And usually the antibiotic, the drug of choice of the antibiotic is cefixime for mild cases, and also ceftriaxone for severe cases, yeah, intramuscularly or intravene. Yeah, so we see here that the penicillin cannot be used anymore, of course. Fluoroquinolone is also not allowed to use for the therapy of gonorrhea. And we see here that the third generation of cephalosporin is still less than 10% resistant. But of course, again, this community-based surveillance is only in a very small area of Indonesia. So I think it is still not represented the whole Indonesia. Yeah, so and also, so I work also in Cipto Mangunkusumo. You know, almost, so every day we do the laporan jaga, yeah. So we discuss about the cases. And actually, the gonorrhea also found in conjunctivitis and also keratitis for infection in cornea ulcer. Yeah, so we have that cases. And it is, I think, maybe in 1 month, in average, is 1 case per month. Yeah, so please also consider that. Adult with conjunctivitis or cornea ulcers with the production of pus, so much pus, and there is no, so already given with the topical antibiotic, but it doesn't work, and it is very profuse, so please think to send the specimen to see the gram-negative coccus bacteria. And the other things also, you heard about the flies eating bacteria from Japan? Yeah, it is caused by Streptococcus pyogenes, yeah? And it is actually also found here in Indonesia. And so I think last month, we found it also from the patient with the very profuse infection in the palpebra and also the eye. Yeah, so it has happened. So just because, I think it's because of the hygiene, sanitation. So please don't only do your hand hygiene during caring the patient, but also in your daily life. Yeah, please use or do always the hand hygiene. Yeah, next slide, please. Yeah, so this is only the conclusion of all I have shown. And the next slide, please. Yeah, so this is, can you make it, yeah. Yeah, so this is also from the last publication. So we compare this to the other, so Malaysia, Philippines, Thailand, Vietnam, and European Union. So the condition in Indonesia, this is, the data come from 3 sources, from the systematic review, from the GLASS data, and from SINAR, which is produced by our professional organization. And all this, the priority pathogen is very, very high and much higher than the other neighboring countries. Yeah, so that's why please don't do the prescription without thinking, because there is actually the step how we think and then actually, finally decide that antibiotic is needed in this patient. So first, of course, you have the data, the anamnesis, physical examination, the data, for example, the leukocyte, yeah, the neutrophil, CRP, and of course the inflammation signs. Yeah? So this is very important data. If you think this is infection, then the next one you have to think the etiology of the infection, because not all infection need antibiotic. Yeah? There are many infection in the community caused by the virus. So antibiotic is not the solution. Yeah. Okay, next one. Yeah, so despite all this very big problem, we have to have the spirit to be better and better, right? So last year in December 2023, WHO has published the new approach to combat the AMR problem. They call it as the people-centered approach. Yeah, so you can also download it from the WHO website. There are 13 interventions in this people-centered approach. And so in my opinion, it is very good, because AMR is actually talking about infectious disease. So that's why in this approach, we have to prevent and detect very early the infectious disease. And that's why there is 4 important pillars. First is the prevention. So we have to also collaborate with the sanitation, hygiene, the provide of the water, air bersih, yeah? And also implement the infection prevention control. The second one is access to essential health services, and this is very difficult in Indonesia. We know geographically Indonesia has a very big variation from Java to Kalimantan and to Papua. Yeah? The third one is timely, accurate diagnosis, and the fourth is the appropriate quality assured treatment. So we have developed this, the national strategy for AMR control based on this, and I think Indonesia is the first country who adopted this people-centered approach, and we will launch it, I think, end of this month. Yeah, so with this, we hope that we can synergy work together with all sector, all directorate. Yeah, you know that within Ministry of Health, there are some directorate, right? For example, health promotion, and then pharmacy, and health services, and also the P2P is CDC, the control disease, yeah, so for community infection, community-based infection. So all of these directorates should work together to achieve the target that we have already determined in this national strategy. So the last slide. Next, yeah, so this is the conclusion that AMR prevalence in Indonesia estimate very high number of critical gram-negative bacteria, and this is also the highest or the higher prevalence of bacteria reported in the Southeast Asian region. And of course, we need high quality and standardized AMR data to provide the good data, and also later on we need to determine the intervention based on the situation. And it is also very important that in the new approach, we have to involve the social science, because this is also important to change the behavior of our people. Yeah, so behavior change is very important, not only the community to be more, more attention in hygiene and providing the water, the clean water, sanitation, but also to change the behavior of our society. So for doctors to give good prescribing. So I think with this, I end the presentation. Thank you very much for the attention. Wassalamualaikum warahmatullahi wabarakatuh.
Insightful presentation. Now I invite Prof. Gita and Dr. Anis to come for discussion session. We start from the Zoom. Is there any question from the Zoom? No? There is no, okay. I open the question from the audience. Is there anyone that want to ask a question to Prof. Gita and Dr. Anis? Ya, dalam bahasa Indonesia boleh. Ayo. Ya.
Selamat pagi dokter, perkenalkan saya Billy Octavian, mohon izin bertanya. Saya ada beberapa pertanyaan. Yang pertama di sini untuk resistensi antibiotik ini apakah dapat kembali sensitif seiring waktu berjalan, dan jika bisa butuh waktu berapa lama? Dan untuk antibiotik itu kalau misalnya kadar luasa terus dibuang sembarangan, apakah dapat menimbulkan resistensi terhadap antibiotik juga terhadap mikroba di sekitar lingkungannya? Terima kasih.
Terima kasih kerana soalan. Soalan pertama, kalau bakteria itu sudah jadi resistant, mereka sudah mengalami mutasi pada level genetik. So dia tidak akan kembali kepada sensitif. So it's like that. So cara yang kita boleh mengatasi adalah penukaran terapi or regime antibiotik. Is it true? Yes. And then yang kedua, yes, yeah. Kalau mutasi itu atas plasmid, bakteria itu boleh menyumbangkan plasmid kepada spesies lain. We call it interspecies transmission. So itu lagi berbahaya. Okay. And bila antibiotik itu sudah masuk environment, itu masalah besar kerana antibiotik, bahan kimia dia tidak akan luput dengan senang. So bila bakteria di environment come into contact dengan antibiotik itu, mungkin it will lead to antibiotic resistance. Did I answer your question? Yes. Thank you.
Mohon izin dokter, kalau misalnya begitu, cara untuk kita mengelola antibiotik yang sudah kadaluarsa ini bagaimana baiknya ya dok, agar tidak terjadi resistensi bakteri ini?
Ya, saya sebenarnya ada peraturan bagaimana cara membuang obat. Semua obat sebetulnya, ya. Jadi tidak boleh dibuang ke sampah, apalagi masih utuh, masih tertutup, terus dibuang. Itu dilarang karena itu bisa diambil lagi oleh pemulung ya untuk dijual lagi. Jadi kumpulkan antibiotik itu kembalikan kepada apotek. Itu adalah aturan sebetulnya yang mungkin juga belum diketahui oleh banyak orang. Mungkin di sini belum ada yang tahu ya. Ya, obat itu kalau sudah kadaluarsa, masukkan kantong, kembalikan ke apotek. Biar apotek yang akan mengelola. Demikian.
Gita and Dr. Anis for the answer. Is there another question? From Dr. Shirley?
Yeah, I have a question for two speakers. Actually, I'm interested that the issue that Prof. Gita has told us about the antibiotic use for promoting the growth of the cattle. So I'm wondering, how is the regulation or policy in both countries, Malaysia and Indonesia, to overcome this situation? Maybe to the breeder and also to the slaughterhouse. Is there any certain regulation or the inspection to protect us as the customer and also as a consumer? Second one is for Dr. Anis regarding the issue about multiple antibiotic resistance. As we know that the prevalence of TBC is still high in our country. So how do we cope, and what is the update issue regarding the TBC treatment? Thank you.
Thank you, Dr. Shirley. For your first question about the policies, I believe in Indonesia and in Malaysia, we do have policies. You cannot indiscriminately use antibiotics for the growth promotion. But the problem is if it's not reported and if the farmers, they claim that the cattle had infection. So they're using antibiotics for the infection purposes. So I think the monitoring needs to be more stringent. I can't tell you because I'm not sure of the monitoring processes, but I'm sure they do have them. But I believe that they should tighten up on the monitoring processes so we can cut this problem, nip it in the bud.
Yeah, so I want to answer also the first question. So we have already the act, undang-undang, for the larangan untuk menggunakan antibiotik sebagai growth promoter. It is published in 2009, but then it cannot be implemented because they need, so some act need regulation for implementation. Because so many pro and cons for this statement, then finally in January 2018, there is a regulation from the Ministry of Agriculture to implement this act. To, apa melarang itu apa sih? So that the use of growth promoter is not allowed anymore. But of course it is very hard, you know, because farm, so maybe more than 10,000 farms in Indonesia. There is small scale farms, middle and big scale farms. Yeah, small farms is around 100 animals, so for a poultry. Yeah, so for example, 100 what do you call, goat or sapi, yeah, cows. Yeah, this is small. And usually the farmer for this small scale of farm is very, you know, they don't have the veterinarian. Yeah, so actually this is also a must that each farm has one veterinarian, but they cannot hire veterinarian in the very small scale farm. So very difficult to monitor and evaluate this regulation. And then also in 2020, I think 2020, in the middle July maybe, there is also surat edaran, yeah, that they don't also allow to use colistin, because colistin is also used very many in all cases in animals, in poultry. So from 2020 there is a regulation also that colistin is not allowed to use in animal sector. Yeah, but it is again very difficult to monitor and evaluate. Yeah, but they always try to do the best, of course, yeah. And the second question about tuberculosis, so I think this is a big problem. We are still in the second rank in the world, yeah. So the first things that 2020 is actually the year of TB elimination, but we don't think that we can achieve it. The first things we do now is to to make the coverage, yeah, to increase the coverage of diagnosis. So that's why now there is so actually not new guideline, but already maybe 10 years, from 10 years ago, we use the molecular testing, the gene expert, and now we have the ultra, what do you call, the ultra, there is another gene expert for TB, with limit detection, lower limit detection, so it's better than the normal gene expert. And also the number of expert machine in Indonesia now is more than 3,000. And it is already distributed in all the puskesmas, primary health care. And also that's why the guideline on how to treat the patient is also based on this molecular system. So it's becoming faster than waiting for the culture. So this is I think the first one. And the second one, also there are some clinical trial to shorten the length of the treatment from 6 months to 2 months. But we're still waiting for the result of this new treatment. Yeah. Thank you.
Thank you, Dr. Anis and Prof. Gita for the answer. We have one question from Zoom to Prof. Gita and Dr. Anis. Once we had a case where the patient's culture results produced gram-positive Staphylococcus aureus bacteria. Then the clinician asked for the result of the resistance test for carbapenem, which is not recommended, and said that he had given the patient meropenem therapy and the clinical patient had improved. How we can give the doctor explanation about this? Maybe Dr. Anis want to answer.
With MRSA or just Staphylococcus aureus?
Aureus, just
Yeah.
without MRSA result.
Yeah, usually we need to discuss. So for this kind of cases, we need to have discussion with the clinician. Why does he or she need carbapenem in this or meropenem in this patient, in this particular patient? You know, Dr. I don't know who asked this. So we need a very, you know, it is very important. So we know that since 2015, there is a regulation from MOH that all hospital has to have AMR control team, yeah? And this team has the obligation to give, to educate and also discuss with this kind of clinician. So that's why if you as clinician cannot convince the clinician to choose other antibiotic, then please contact the AMR control team. So through this team, maybe we hope that the discussion will can convince the clinician. So sometimes it is very difficult to convince the clinician because maybe the patient is very severe, for example, but we have to, you know, to see how severe is the patient. Yeah, is it carbapenem needed in this patient, for example, and also is there any other source of infection? So maybe this patient is becoming severe not because of the Staphylococcus aureus only, maybe also due to other infection, yeah, which cannot be, maybe cannot be culture, yeah, for example, yeah. So we need to discuss about this patient, yeah.
Maybe because of the limited of time, we only one question from Dr. Novi Wijaya. Good day, my name is Dr. Novi. I would like to ask about resistance of antibiotic. Is there any tools faster than conventional culture regarding the need of faster treatment?
Thank you very much for the question. There are molecular tests available, PCR especially, and they also have other systems. So it is faster detection, but it's whether you have access to those particular diagnostic tools. Otherwise, culture and sensitivity is still the gold standard, but it does take a long time because you have to culture the bacteria, identify the bacteria, and then based on the pathogen that you've identified, then you choose the antimicrobials to do the culture and sensitivity. But yes, there are molecular detection tools available.
Yeah, so I just want to add that even though it takes more than maybe 3 or 5 days for culture, but you can still give the empirical antibiotic for this patient, so don't worry. So just give the empirical antibiotic and then you can change it to the definite therapy after you get the result of the antimicrobial susceptibility test?
Thank you, Dr. Anis and Prof. Gita. I think it's clear. Maybe another question we will answer one by one at the Zoom. Later we ask the speaker. Now this is the end of the session. Give a big applause to our speaker. I giving back to Master of Ceremony.
Thank you, Dr. Donatilla. That was a very insightful session. Thank you to our doctors and moderator. And now we'll be giving a certificate to our speakers, Professor Dr. Gita Subramaniam, Dr. Anis Karniawati, PhD SPMK Konsulen, that will be given by the Dean of the Faculty of Medicine, Universitas Tarumanagara, to Professor Dr. Gita Subramaniam, Dr. Anis Karniawati, PhD SPMK Konsulen, and Dr. Nur Salan Tajudin, SPKJ. Please occupy the designated place. Thank you to our doctors. We have been waiting for this too. The second session of the seminar, consisting of 3 topics, relapsing bacterial infections, antibiotic tolerance and persisting cell types, by Associate Professor Dr. Stephen Kidd, Microbial biofilms and the issue of antibiotic resistance, by Associate Professor Dr. Gayatri Guru Rajan, and Green Medicine, Exploring Plants as Antibiotic Alternative, by Ms. Lalita Ambigai Siva Samugam. This session will also be guided by our moderator, Dr. Donatilla Mano, SPMK. To Dr. Donatilla Mano, the floor is yours.
Yes. Thank you for the MC. Now we please just start the second session with the Associate Professor Dr. Stephen Kidd from Australia will present the topic about relapsing bacterial infection, antibiotic tolerance, and persisting cell types. The CV of the Dr. Stephen Kidd we can see from the screen. Yes, Dr. Stephen Kidd, the times and floor is yours. Dr. Kidd? Oh, yes.
Okay, thank you very much. Let me just get my screen all sorted out here. And what I'll do is hopefully that can be seen. So hopefully I'm sharing my screen with you now. Can you see my slides? Oops. Okay.
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 We can see the slide already, Dr.
Okay,
Stephen.
excellent. That's really good. I was just trying to. Okay, so firstly, I'd like to say how grateful I am for the invitation and the wonderful experience of joining you today and the great talks that I've heard already. So hopefully I can add to that discussion with some of my specific work that we're doing here. So yeah, like was said, my name is Dr. Stephen Kidd, and I'm from the University of Adelaide in Australia. And actually, I'm the Deputy Director for an Australian centre that works in lots of different variations of antimicrobial resistance. So we're the Australian Centre for Antimicrobial Resistance and Ecology. We have different sites around Australia, and we join together people who work on bacteria and parasites and viruses, but also people who work in the environment, in livestock and companion animals, and in human health. And we see if we can kind of join together to have a One Health approach to trying to tackle antimicrobial resistance. And very specifically, I'm sit here at the University of Adelaide as part of that centre, but I'm in the Department for Molecular and Biomedical Science. So what I do is I work on the molecules in the genes of specific bacteria that actually develop into relapsing bacterial infections. And one of the core things that we look at is slightly different to some of the talks beforehand. Is we look at a concept around antibiotic tolerance and the unusual cell types that avoid detection and treatment. And one of the spectacular things that scientists and clinicians and the medical professionals in general can do is they can look at an infection and they can very accurately detect the bacteria that are present, and they can use global standards for testing for antibiotic resistance. So they can identify a bacteria and identify which antibiotics should work and should not work. And even so, despite all that great medical science, there are a lot of infections that relapse with the same bacteria, and that's what we work on. And what I'm going to do is spend the first part of this talk describing that concept around antibiotic tolerance and what persisting cell types are in the context of my research, and then I'm going to give some examples of how we do this in collaboration with some hospitals here in Adelaide. So we've got some really neat projects that are looking at specific infections. Okay, now one of the interesting things is that bacteria can colonize humans, and they can colonize anatomical niches, and they need to adapt to those environmental conditions, the physical and the chemical conditions of particular anatomical niches. So for instance, if a bacteria is living in the gut, that's going to be different in terms of physical conditions, the temperature, etc., the pH, compared to a bacteria that colonizes the skin or the nose. And we've tried to understand how bacteria respond to those stresses, and some of those bacteria can adapt to those stresses and then go on and cause a disease. And then on top of that, we then intervene with some kind of accurate medical intervention, such as antibiotics, which is the main response to an infection when it gets to that point. And I'll deal with that in a second. So we've got this idea, this paradigm of how bacteria respond to stress, and then quite separately how they respond to antibiotics. And one of the neat things that has developed in the last 10 years is, as laboratory scientists, we like to reduce things down and study single kind of aspects or elements of a problem. And what's developed over the last 10 years is there's actually an interplay between all these different aspects of what's going on when bacteria respond to stresses in an anatomical sense, compared to what goes on then when they are being assaulted by antibiotics, for instance. So what I'm going to do is I'm going to really quickly go through this slide. It's quite complex, but the major thing here is we've got a pathogen, and at this point in time, it's not a specific bacterial pathogen. It can be gram-negative, positive. It could be Staphylococcus aureus. It seems to be gold, but these little bunches of spherical cells here depict a pathogen that is colonizing human, an anatomical niche, and these can be different cells. They don't necessarily need to be immune cells. And as part of this interplay between the bacteria and the host cells, there are production. In the host, there's a range of stresses that the bacteria need to adapt to, such as nutrient starvation. There can be very specifically a battle for things like iron and other metal ions that are essential, zinc and copper, for instance. There can be changes in the oxygen, which change how the bacteria is able to grow. And there's nutrients and pH that are altered, and these all put on a stress to the bacteria. If this develops, what we end up with is a very specific response by these host cells that produce reactive oxygen species, which are these things here, these ROS things, and reactive nitrogen species. So these are reactive chemicals that very specifically target the membranes or the proteins of the bacteria, and they're designed as antimicrobial processes that host cells have. And I emphasize the word host cells because these can be on the precipice of infection and don't necessarily need to be immune cells, although they quite often are. So in amongst all this, the bacteria can actually adapt to these conditions, and they need to respond very specifically to this chemistry that's going on. But then as the bacteria responds, there is a disease, and there will be an intervention, which is, let's say, it's antibiotics. So very nicely, Professor Geetha talked about antibiotics and how they work. And, the antibiotics can have an interplay with those chemicals as well as being directed specifically against the bacteria. Now, I'm not going to go through this slide because Professor Geetha discussed this really, really nicely. So the targets for antibiotics are things like the cell wall biosynthesis, DNA replication. They are the processes such as transcription, which is the generation of mRNA, or the generation of proteins, or metabolism. And all those sort of aspects, there are different classes of antibiotics that target those things that are really important in the ability of the bacteria to survive, but let's say very specifically the bacteria to grow. And I think that's actually really, really important. So what the bacteria can do, and once again, Professor Geetha talked about this, how the bacteria have genetically encoded traits which allow them to resist those antibiotics. So for instance, that it could be an enzyme that inactivates the antibiotic, or it could be an efflux pump that pumps it out, pumps the antibiotic out, or something like that. Once again, I'm not going to go through the details of that, but these are genetically encoded traits. And these traits can be passed from one bacteria to another bacteria to increase the number of cells that harbor these genetic traits, which give the bacteria an antibiotic resistance. The thing that we've understood in the last little while, though, is that antibiotic resistance, those genetic traits, do not tell the whole story. And that's the research that we come into. So we started with the really dark gold body of cells, but actually in a real world situation, within a host, within an anatomical niche, even though it might be one bacterial species that's colonized there and causing a disease, there are variations in those cell types. So there are different versions, for instance, of Staph aureus that exist within an isolate that is infecting and causing a disease. Now, I think a little bit later you're going to hear about one of these cell types that goes on and causes biofilms. There are other cell types that switch off their growth. So indeed, what they do very specifically is they might switch off the DNA replication, or the processes that make RNA, protein, or the processes for the biosynthesis of the cell wall. So all those things that are the exact targets of the antibiotics that are really important for bacterial growth, there are cell types within this population of infecting bacterial cells that exist. And sometimes these cell types are called L-form cells. So these are really odd kind of cells that don't really produce any cell wall. They're not really growing. And there's another form of bacterial cells that almost become dormant. And these are referred to as small colony variants, or SCVs. And these are different to cells that produce a biofilm. So if I put this cartoon up really to summarize those last few slides, and just to go over the key points once again, is we have a population of bacterial cells, and these might initially colonize a host, and then as they colonize the host, they're attacked by a range of chemistry and physical conditions. So some of these are reactive oxygen species, and that population of bacterial cells will diversify. So there'll be a diversity of bacterial cells that are colonizing, and then there'll be a response by host cells. There will be a disease as an outcome of this interaction. There'll be antibiotics thrown at the bacteria. And the antibiotics, as we heard, target those processes that are really important for the bacteria to grow. So the antibiotics will be selected firstly by the very clever clinicians and the medical professionals who will say, we're not going to use antibiotic A because it tests as being the bacteria tests as being resistant. We're going to use antibiotic B. So we'll use antibiotic B, and it will target the population of cells, but it will only kill the actively growing cells. So what we end up with is this circle on the right, where we end up with the slow growing or the quasi-dormant or dormant bacterial cells, the cells that are viable, but they're not actually growing. I'm not going to talk about biofilm, but there are a variety or diversity. For instance, Staphylococcus aureus is a really good example. Even the susceptible cell types have a subpopulation of persistent cells, such as persister cells, L-form cells, and SCV cells. Okay, so and that's where we're really interested in finding out how these cells are tolerant of antibiotics. And so I'm going to focus on Staphylococcus aureus, and in the next little while give some background as to what we know about its response to antibiotics and its disease, and why it's able to cause relapsing disease. And Staphylococcus aureus is a really great example. There are methicillin-resistant versions that harbor a lot of genes that provide them with resistance to specific genes, specific antibiotics. But the methicillin-sensitive Staphylococcus aureus is also really, really serious as well, because it can change how it grows to cause relapsing infections. And the example I'm going to give here is for diabetic foot ulcers that get treated initially with a silver-based wound treatment. The diabetic foot ulcer progresses on to be an infection where antibiotics are introduced. And in a large number of these cases, they relapse. And the reason for that relapse is still a little bit of a mystery. And so there's lots of different factors that are at play why we can get relapse. It might be an error in the diagnostic or treatment regimes. It can be, if I go back there, it can be reinfection by a new bacteria. But a lot of the data coming out around the world is that quite often it's because the original bacteria wasn't properly cleared. The other reasons why we get relapse is because there's a dysfunction in the immune response. And obviously there can be the bacteria harbor antibiotic resistance. However, one thing that I do a lot of work with surgeons and with doctors and people in health departments in different parts around the world, actually, but here in Australia especially, and they're not silly people. They look at an infection and they're quite thorough in making sure they're using the correct antibiotic. So, it should work. And when the treatment doesn't work, it's confusing. So the two aspects that we work on, the original population of cells harbored a lot of cells that were susceptible, but there were some that weren't being cleared despite being susceptible. And this is a trait that is referred to not as antibiotic resistance, but as tolerance. Okay, and there's lots of different bacteria and examples that I could give that display this trait of antibiotic tolerance, but I'm going to talk about Staphylococcus aureus, and there's lots of different reasons for this. It colonizes the nose and the skin, and in recent research in the last 12 to 18 months, it seems to also colonize the gut in low numbers as well, and it sits there in healthy people over a long period of time. So during that time, it's adapting to the host environment and those physical and chemical conditions, but it also is quite metabolically robust. So it can grow with very, very low or no oxygen. It can use different carbon and energy sources, and it can infect lots of different sites around the body. And even in a asymptomatic context, but then when it goes on and causes diseases, it's quite unusually can cause diseases all around the body. So it can cause skin and soft tissue infections. It can cause lung infections. It can cause endocarditis, infect the heart. It can cross the blood-brain barrier. It can infect the bone and cause osteomyelitis. And it can also really seriously get into the blood and cause sepsis. And with a lot of these infections, there are some more than others. A lot of Staph aureus infections become chronic or relapsing, and that's a real problem. Actually, I'm not going to go through this. MRSA is really, really well studied, and there's lots of really key genes that Staph aureus can harbor on particular cassettes, on large cassettes, so large bits of genetic information which have different genes for beta-lactam resistance and lots of different resistances, and and that provides the bacteria with a skill to be resistant to antibiotics. So that's a genetic trait that provides an efflux pump or an enzyme to break down antibiotics, and that genetic trait we can actually identify with really neat PCR-based technologies, and we can say, oh, look, this strain has these genes, it's going to be resistant to those antibiotics. But it's actually a lot more complex to that. And there's a series of particular relapsing infections. And like I said, I'm going to focus on the diabetic foot ulcers that originally diabetic foot ulcers are diagnosed as not being infected, and they get treated with wound healing creams that try and stimulate the cellular and immune responses required to heal a wound. And then alongside that, there are antimicrobial additives, usually silver or something else, that are put in, and this is to heal up the wound. Now, there are bacteria present. Surprisingly enough, even though there's no infection, bacteria do survive in this DFU. And actually, there's a really large number of these diabetic foot ulcers or wounds that progress onto an infection. It's in excess of 50%. And so it does become an infection, which is quite horrible. And these infections become quite hard to treat. Obviously, the gold standard for treatment is to identify the bacteria, do testing for antibiotic resistance and susceptibility, and then use antibiotics. And when that doesn't work, when we've got relapsing and chronic DFIs, diabetic foot infections, the bacteria can then transit and get into the bone. And actually, that's actually really, really serious when it gets into the bone, because the antibiotics don't work. The bacteria can then spread throughout the body, and they can cause sepsis and can be fatal. So the treatment of diabetic foot osteomyelitis or bone infection is actually an emergency procedure, and it requires amputation. Now, well, let me just finish there. So what happens is we get an ulcer that goes into an infection, which goes into the bone, and we have amputation. So the surgeons will cut off the infected tissue, and then they will nibble back into the healthy bone just to make sure that they've got everything. However, despite that, about a third or more, or after amputation, a third or more will relapse and will become an infection again, which is quite stunning, really, because they had done everything they could to get all the infection out, and I'll come back to why we think there's relapse. So once again, what we have actually is a change in our view. This is what I discussed before. We have a change in the view over the last 10 or 15 years from a clonal bacterial cell population with all the cells on the left there, they all look the same and we deal with them the same. So that if we test and say that the infection is antibiotic susceptible, we're assuming that all the cells within that infection are susceptible, and that's not necessarily the case. And so what we have is I'm going to focus on, we have a diversity of cell types, and one of those cell types are these phenotypic variants called small colony variants. And actually, these have been identified for over 100 years. People would isolate some bacteria from an infection, from a lesion, and for instance, with Staph aureus, you get nice gold colonies when you grow the bacteria. But in amongst those gold actively growing cells, on the left here on an agar plate, there will be non-pigmented. These take a long time to grow, a lot longer to grow, and they don't produce a lot of the cell wall components. They don't have a capsule, they don't have a pigment, and they're non-hemolytic. They're quasi-dormant, so they're very, very slow growth. They have very little ATP. They aren't viable cells, but they're not going to be killed by antibiotics. And so these remain present because they don't have a lot of the cell wall components. They're not stimulating an immune response. So they're hidden from the immune system and they're not killed by the antibiotics. So what will happen is they will sit in healthy tissue. So for instance, after the amputation and when the surgeons nibble back into healthy tissue, even back from that, within that healthy tissue that's remained, there can be these small colony variants that are not producing a disease, and then they can revert back to the gold active cell types to cause a relapse of infection. So that's exactly what we think is going on. Now, with small colony variants, there are a couple of ways that this has happened. One thing that people find is that there's a subtle change in their production of the cytochromes that produce ATP. So the electron transport chain is defective, so we don't get the cell wall being produced and there's very little ATP. But, we get a lot of clinical samples and, the bacteria are very, very hard to grow. So the major question that we had probably about 10 years ago is how do you grow bacteria that don't grow? Now, I'm not going to go through a lot of detail on this, but one of the really interesting things is that, way back in the 1950s, Jacques Monod started to grow bacteria in a very innovative way to define their metabolism. And that's actually a lot of hard work. So what we do now is we try and keep it simple and we put the bacteria in a closed system in a flask. But, if we think about what Jacques Monod and together with André Luff and Francis Jacob, they got a Nobel Prize for defining how bacteria grow with particular carbon sources. And what they used was a continuous culture system, which is a chemostat. This is not a picture of my lab, but this is where you've got a continuous culture where the bacteria or the media are flowing through and then flowing out. So it's not in a closed system. And actually, it allows us a very good way of defining all the bacterial cell types that are present. So let me just confirm that. So if this picture here of a flask with some media, and the way that commonly laboratories study this is they inoculate in bacteria into this flask, and we'll get the bacteria growing through a lag phase and then logarithmic phase, and then going into stationary phase. And the bacteria go into stationary phase in this system because they've used up all the media. Now, for these very, very slow growing bacteria, they're not going to even start growing at this point in time, so we'll never get to see them. So what we do is we've set up something a little bit more modern than what Jacques Monod and his colleagues had. We've got this continuous culture system that allows us to control the growth rate, have a steady state, continuous growth. And this has allowed us to look at all the different cell types that are present. And indeed, what we do is we do this over a long period of time. This is over 60 days, and we get an increase in the percentage of small colony variants. And we add in different chemicals to see how the bacteria respond to that. And really quickly, what we can see is that the bacteria respond by changing from being just gold colonies to these diverse cell types, which include small colony variants. And over 60 days, that's a lot of generations of bacteria. And we've tested these different generations of bacteria against antibiotics, and we've seen that they now are not killed by antibiotics. So we're interested in what has happened. As Professor Geetha said, sometimes bacteria over a lot of time, when you pressure them, they will mutate. So we looked at whether they'd acquired any genes or mutations for antibiotic resistance, and they hadn't. What they'd required is changes in their ability to grow. And very specifically, there were genes that there were two big gene regulators, RSBU and MGRA. And the bacteria, by changing these particular genes, are able to change how they grow. For instance, they down-regulate a lot of their cell wall biosynthesis, the capsule and the carotenoid, the pigment, and they upregulate a lot of protective things such as some surface proteins. And one of these surface proteins we're using as a little bit of a future study at the moment to see whether we can use this to identify small colony variants present in infections.
Sorry, Dr. Kit, your time is 5 minutes more. Thank you.
Okay, excellent. That's perfect. I wanted to highlight that what we've got here is we've got a zone of clearing around an antibiotic, and these small colony variants, so this is this clearing on a disc, this is oxacillin, and this would show that we had sensitivity. So with these small colony variants, what they do is they exist within the zone of clearing, and if we culture those, they will then grow all the way up to the antibiotic. So that this trait of antibiotic tolerance actually provides the cells with a complete ability to grow in the presence of the antibiotic. Okay, so I've talked a little bit already about the projects that we have with some hospitals and diabetic foot ulcers, and how a diabetic foot ulcer will progress into the bone, and how even if we cut that away, we end up with a relapse of infection. Now, if we look very closely, a project that we've had is to look here sort of deeper down from the amputation and say, well, how in that healthy bone that's getting nibbled back, if it's healthy, are there bacteria still present? And just in the last minute, I'm going to skip through and just show you. So what we've been able to do is we've been able to do some neat cell biology and some molecular biology together with some microscopy, which probably looks easier actually. So this is a bone cell, an osteocyte. In the top left here, we've got some transmission electron micrographs, and inside the bone cell, these small colony variants. So what happens is it turns out that Staph aureus when it causes an infection, sits outside the bone cell and causes the bone to respond. But these small colony variants actually get inside the host cell. And by doing that, so when they're inside the host cell, they're hidden from the immune system, they're hidden from antibiotics, and they can actually sit inside healthy tissue for a long period of time without disease and then revert to cause a relapse of infection. So that's where we're working at the moment. So we've got some really neat projects to use molecular and genetic tools to try and see if we can find these hidden bacterial cells. We're also trying to determine how the bacteria switch to small colony variants and whether we can develop biomarkers to identify these antibiotic tolerant cells. And then there's some really nice study that we're doing with some chemists to look at nanoparticles and see if we can use some nanoparticles that don't only target the actively growing cells, but they also target the slow growing or dormant cells. So just to finish, the work that I've done, I should acknowledge the PhD students at the top left there who've done the work, and I collaborate really closely with other researchers at the University of Adelaide in the Centre for Orthopaedic and Trauma, and Professor Gerald Atkins there, as well as people at the Royal Adelaide Hospital down to the right there with Professor Robert Fittridge. So thank you all for listening. I know I got through quite a lot there, but that's great. So thank you, and I'm happy to take questions a little bit later.
Thank you, Dr. Kit, for your excellent presentation. Just wait for a Q&A session after all the speakers. Now we call the second speakers is Associate Professor Dr. Gayatri Gururajan from India. We'll talk about microbial biofilms and the issue of antibiotic resistance. Dr. Gayatri, Prof. Gayatri, the floor is yours. Let's see the CV of Prof. Gayatri. The CV of Prof. Gayatri. Okay. Expertise, specialization in bacterial multi-drug resistance. Present as Associate Professor in Kanchipuram, India. Prof. Gayatri, it's already on the Zoom. Hello, Prof. Gayatri. Is Prof. Gayatri already at the Zoom? Prof. Gayatri, can you hear my sound? Prof. Gayatri? Excuse me, Prof. Gayatri.
Hello, ma'am.
Oh, yeah.
Can you hear me?
Can you hear my
I've logged in
voice?
with an IP Rajyoganan. I'm not able to. Now I can.
Oh, okay. Can we show the presentation of Prof. Gayatri? Yes. Okay. Prof. Gayatri, the floor is yours.
Is my screen visible?
Yes, already.
Thank you. Good morning, ladies and gentlemen. I take
Morning,
this
Prof.
opportunity to thank the organizers for having me as a part of this international seminar on antibiotic resistance, the silent pandemic, which is the need of the hour. I congratulate the organizers for taking up this topic and to to spread the awareness among our young researchers, student community, and all the stakeholders so that we will try to combat this problem. Without taking much of your time, I shall address on the topic microbial biofilms and the issue of antibiotic resistance. So these are the topics I'm going to talk about. The biofilms. These are a highly organized three-dimensional structures that exist as complexes formed by multiple species of microbes. They exist as microbial communities and are held together by a covering called the extracellular matrix. These communities are formed by the association between prokaryotes and or eukaryotes, including bacteria, algae, archaebacteria, amoeba, flagellates, yeasts, and even fungi. To put in the words of Penzian, biofilms are the unique incubators of diversity for the microbial world. These biofilms can be formed on both biotic surfaces like living tissues and abiotic surfaces like glass, plastics, pipelines, and marine environment. Now, what are these biofilms made of? Well, the biofilms are polymeric in nature and usually produce an outer protective structure that is commonly referred to as the ECM. And this ECM is a self-produced one and is composed of up to 90% of total organic compounds, carbon compounds. In addition to that, polysaccharides and proteins, nucleic acids in the form of extracellular DNA and extracellular RNA, lipids, and water. Interestingly, around 95% of the biofilm contains water. Another interesting feature of biofilms is that how do they interact? They interact among themselves both symbiotically and antagonistically. For instance, cells in the biofilms produce antibiotics to create a competitive environment for others, and likewise, they also protect the other cells within the biofilms from being attacked by external colonizers. In simpler terms, we can refer the biofilms similar to a holobiont, a collection of species that are closely associated and are interacting. Let me get into the brief history of microbial biofilms. Biofilms have a long history dating back to 3.4 billion years ago. Recent studies have revealed the presence of fossilized microbes in rocks at Barberton Greenstone Belt in South Africa, mountain ranges. Scientists have discovered that some of these fossilized structures were grouped together in formation that resemble the biofilms. And of course, Leeuwenhoek in 17th century, he found the presence of microbial aggregates in plaque samples from his teeth. And simultaneously, workers were carrying out many investigations, and it was Bill Costerton who coined the term biofilm. And he was one among the pioneers working on biofilms and their significance in human health. The logos that are shown here, they indicate the coordinated efforts by different groups of scientists, researchers, and industrialists who are working on combating the problem of biofilms in terms of antibiotic resistance across the globe. The biofilms are complex microbial communities. They are embedded within a matrix, or more appropriate term will be a matrix zone, which are adherent to inert particles or inert surfaces. We can see some basic properties of biofilms. They can be monomicrobial biofilms or polymicrobial. Monospecies or monomicrobial biofilms, the single species of microbes constitute in this monospecies, and they can be existing as either separate colonies or microcolonies or aggregates. Whereas in multi-species or polymicrobial biofilms, we can see a mixed species of microbes within the architecture, but they exist as separate microcolonies or co-aggregates. So the interactions among these polymicrobial species can have an impact which can be both beneficial or detrimental. Beneficial part we'll see, the detrimental part, which will be more related to this theme of the international seminar today, they hinder the antimicrobial treatment. As Dr. Kidd has suggested, the biofilms caused by Staphylococcus aureus, a well-known, notorious pathogen, especially the MRSA strains, they have the ability to form biofilms, not only among themselves as a monospecies, but also they have the ability to form polymicrobial biofilms, especially with the species. And treating one antibiotic-resistant microbe is difficult, and combination of different taxa are much more difficult, and this results in complicated therapeutic strategies, sometimes even may result in treatment failure. According to Donlan and Kostetak, a biofilm can be defined as a microbially derived cell community characterized by the cells that are irreversibly attached to the substrate or interface or to each other, and they are embedded in a matrix of EPS that are produced or exhibit an altered phenotype. That's very important with respect to growth rate and gene transcription. Now, where do these biofilms are found actually? So these can be found in both terrestrial, and recent evidences have suggested that to be found even in extraterrestrial space. When you see this slide, we can see the diverse habitat of biofilms. We can find them in healthcare industries where they pose a threat in device-related infections, in food industries where they can form biofilms within the food pipelines and food utensils, and so that they can gain entry into the food. They can even be found in personal products, home care products, in built-in environments like water tanks for storage, mechanical, civil engineering applications. And also we can find them to be employed to treat wastewater. They are also causing problems in biofouling, especially in the marine environment, biofouling of ships. Space biofilms are a recent interest of research where we have been getting increasing reports about the prevalence of microbes in space. The prevalence of biofilm community in space is a very important topic of interest. The International Space Station has been inhabited continuously for over 2 decades. The environment within the ISS is designed for the comforts of the astronauts who are working on Moon and Mars missions. However, the safety can be jeopardized or compromised due to the conducive environment for other life forms too. Microbes have been found to be associated with the surfaces, and they exist as biofilms and may be a source of problem in the functionality of equipments in the ISS, or they can even pose a health threat to the astronauts. In this slide, we can see a picture to our right showing mold growth in the panel within the ISS, and we can also see the biofilms that are formed in the plumbings. And the picture in the center shows a emerging pathogen, a re-emerging pathogen to be more precise, MDR, Enterobacter bugadensis, which has been recently identified in the ISS. And it has been evaluated for the association with microbial communities that occupy specific niches in the ISS. So now we know that the biofilms are not only limited to terrestrial environments. The discovery of space biofilms have opened a new avenue for research and also in the understanding of how do these microbes adapt themselves within the biofilm to different environments. As for the characteristics of biofilm formation, we can see the step-by-step process, a perfect machinery. The first step in the biofilm formation is the attachment. The attachment of a free living cell, also called as a planktonic form, to a biotic or abiotic surface via their own cellular appendages or through physical interactions with the surfaces. This process is usually reversible, one in the beginning, but as the biofilm develops, it becomes irreversible attachment. Upon attachment, further complex mechanisms aim in firm attachment, which results in the irreversible bond. And this is enhanced by the development of extracellular appendages, special adhesion molecules, or even by upregulating their genes. Due to the high population of the cells within the biofilm matrix, existing as microcolonies or aggregates, a well-defined protective matrix is formed, and this develops into what you call it as a mature biofilm. Now, the aggregation of the microbial species, when they form a biofilm, create what we refer to as scaffolding points. This will enable other microbes to associate with the primary microbe. The process goes on and on, resulting in a symbiotic aggregation between a variety of species. This results in co-aggregation. And this is very important clinically, as they are involved in disease progression and also the development of antibiotic resistance. Further upregulation of genes can occur within this biofilm cells, and this can be mediated through quorum sensing molecules, release of polysaccharides, release of extracellular DNA, etc. When more microcolonies or more microaggregates develop, as a result of this, we can see the accumulation of toxic products occurs. There will be a depletion in the nutrient, and this leads to a dispersal of cells. That is something that very similar to a cell death from the biofilm, which is the last stage in the life cycle of the biofilm. The dispersed free biofilms, the cells from the biofilm, can then form or develop a new biofilm again, and this cycle continues. About the characteristics of biofilms, there is plenty to talk about. This picture shows characteristic features of a bacterial biofilm. When a biofilm is formed, they aid in absorption of molecules, attachment to surfaces, dispersion, formation of colonies, and everything. And how do they differ from sessile cells? They have increased metabolic activity, they have increased growth rate, gene expression, transcription, and increased translation. They also have differences within the microenvironment, showing characteristics of high osmolarity, nutrients capable of more nutrient synthesis, and increase in the cell density. When microbial cells develop or form within the biofilms, they protect the bacteria within the biofilm from the environmental stress. And this is mediated by expression of certain genes. There are different genes responsible for different formation among the bacteria and other organisms, other group of microbes also. Overall, the contribution of biofilm to the microbial cell will be the capacity or the ability to resist antibiotics, to colonize medical devices, or to invade the host. They can establish the pathogenesis, or even they can help in overcoming the host immunity. And they are having excellent cell signaling mechanisms, what we call it as quorum sensing. Microbial biofilms have certain features that are similar to multicellular organisms. They share the characteristics of being heterogeneous in nature and also carrying out division of labor. Biofilm can carry out specialized functions. In polymicrobial biofilms, we can see microbes present within the biofilm that are that are constituting from different taxonomic groups. For instance, biofilm in marine environment are oriented towards specific niches. The aerobic species can tend to be prevalent in the upper layers of the marine environment. They consume the oxygen, creating a lesser oxygen concentration in the deeper layers, enabling the anaerobic species to be prevalent in the deeper layers. In the monolayered biofilms, in a monospecies biofilms, the cells within the same species, they are organized into different groups. For instance, the biofilms in Pseudomonas. Some cells, they become motile to enhance the pathogenesis, for nutrient uptake or any other functions, and some will reside within the biofilms as non-motile cells. Biofilms can also function similar to organ or a circulatory system. The perfect example is water. I told that, if you remember, we saw that the biofilms contain around 97% of water. These water act as channels, something resembling the blood circulatory system, where they transport the nutrients and molecules within the macrosome. Moreover, we can also find that interesting reports have been stating that the digestive enzymes present themselves in close proximity to the cells in the niche, aiding the cells to digest or dissolve polymers. Biofilms can also show behavioral adaptation. They exhibit what we call it as quorum sensing mechanisms. This is an extracellular signaling process, aiding the communication between not only the cells of the same species, but also with the different species. This quorum sensing mechanism enables the cells within the biofilm to recognize, to respond to environmental stimuli, and also aid in transitional state from being sessile to a motile state. Biofilms adapt to environmental conditions. They exhibit changes in their gene expression. The changes can be either temporary or permanent, and they enable the cells in biofilms to evolve into new complexes. For example, few cells in the biofilm, when they are exposed to sub-inhibitory antibiotic concentrations, these cells, they mutate themselves and show increased ability to resist the antibiotics. Biofilms can also maintain homeostasis. As we saw in the life cycle of biofilms, the cell dispersal from the mature biofilm is something that is very similar to the cell death. This results in enhanced entropy. And a new biofilm formation can occur from dispersed cell or cell aggregate. The cells in biofilms can also interact or counteract. There is a sort of competitive interaction as well as a cooperative interaction, which we have seen already. The metabolites or substances secreted from few cells within the biofilms can prevent colonization from intruders. Likewise, utilization and breaking down of complex nutrients by some cells or some species within the biofilm enable to release the simple nutrients which can be utilized by the other species within the biofilms. The significance of biofilms is very important. Biofilms exert a major impact on health. According to the US NIH, over 80% of microbial infections are mediated by pathogens that have the ability to form biofilms. This further fuels the problem of antimicrobial resistance, making the therapeutic options limited or even useless. The biofilm affect the global economy in terms of medical and human health. And it is estimated that infections mediated by biofilms cost around $387 billion globally. More than 70,000 people are infected with biofilm-forming pathogens responsible for cystic fibrosis across the globe. Likewise, around 150 million people suffer from urinary tract infections every year, and the global cost of catheter-associated urinary tract infection management is estimated to be around $1 billion US. So biofilm exert a drastic impact on human and animal health. They pose food safety challenges. They contaminate drinking water supplies. And in industry sectors, they disrupt production from oil and gas wells. On the brighter side, biofilms can also have beneficial effects too. Microbial biofilms are employed in wastewater treatment processes where genetically engineered microbial consortia are utilized to process the wastewater. In the agriculture sector, microbial biofilms are used for increasing the bioavailability of nutrients in the soil. For example, Bacillus subtilis, along with other microbes in the soil, enhances the nutrient uptake by plants, and this accounts for increase in plant biomass, accelerated plant growth, increase in the weight, etc. Biofilms are also utilized in the bioremediation processes. For example, they are applied in the bioremediation of contaminated groundwater and soil, in the bioremediation of oil spills in oceans and seas. Alkonivorax bocumensis, an interesting organism, is an important biofilm bacteria that are being employed in the bioremediation of oil spills. Biofilms are also used in food fermentation. Kombucha, a fermented food, contains consortia of microbes, Acidobacter, Lactobacilli, Gluconobacter, and even some yeasts. They can also serve as food for birds and aquatic animals. The biofilms are also utilized for bioleaching, where they are especially applied in the extraction of gold and copper from the mines, from the ores. Thio species is of particular interest that are found to be existing within the biofilm. They are being genetically engineered for this extraction process. To summarize, biofilms are also beneficial, and the global wide biotechnology market is around 310 billion US, and by 2032, it is estimated to increase to a further 10% to reach around 755 billion US. The microbial consortia in the biofilms are exploited for the production of value-added products like industrially important enzymes, bioplastics, detergents, biofuels, packaging materials, vitamins, amino acids, semi-synthetic proteins, even bioconcretes for the applications in materials research, food, pharmaceutical, and in agriculture sectors.
Excuse me, Prof. Your time is 5 minutes more. Thank you.
Okay, I'll be a bit faster. The biofilm-mediated infections accounts for higher morbidity and mortality in terms of human health. About 78.2% of chronic wound infections are caused by biofilm-forming pathogens, accounting for $281 billion US. Cystic fibrosis infections caused by biofilm infections in lungs are resilient to antibiotic treatment, and they are usually composed of polymicrobial bacteria and fungi. In central venous catheters, microbial biofilms cause infection via migration along the surface of the catheters, bypassing the skin and subcutaneous tissues. All these can result in increased or prolonged stay in the ICUs. We can see some examples of the polymicrobial biofilm infections in humans. We can see the economic burden of biofilms in different sectors. Now, to address the biofilms association with the AMR, after the COVID-19 pandemic, the incidence of AMR has increased. The global consumption of the access group of antibiotics, rightly put by Dr. Geeta, the antibiotics in the aware list has mounted up to 60% according to the global antimicrobial resistance and use surveillance system, shortly referred to as GLASS, an initiative by the World Health Organization. biofilm formation in drug-resistant pathogens is a serious threat in medicine. The mechanism of biofilm-induced AMR include both physical and biological. For instance, the EPS, bacteria and biofilms, helps by stabilizing the biofilm matrix, help acquire nutrients to modulate chemical gradients, maintain microenvironment, etc. The environmental factors also contribute to AMR in biofilms. The hypoxia in the infection site creates a lower oxygen environment. This in turn promotes the virulent gene expression. Acidosis and metabolism, production of slimy layer all contribute to increased resistance to antibiotics. The biological mechanisms, including the AMR, differ with different microbes. We have seen this in the presentation by Dr. Geeta, and she has explained the mechanisms of antibiotic resistance. Relating to biofilms, the AMR in biofilms actually show a reduced penetration of antimicrobial agent by increasing their expression of efflux pumps, an altered microbial physiology, and genetic changes in the cells. The efflux pumps are significant contributors of antibiotic resistance in bacteria. The genes for efflux pumps are upregulated and held by the bacteria to resist antibiotics. They contribute to AMR by making cells to efflux or pump out the drugs to reduce the antibiotic concentration. The quorum sensing molecules also contribute to the cellular interaction. The second messenger molecule like cyclic di-GMPs promote the biofilm formation and influence the antimicrobial resistance by the bacteria. The regulatory molecules help in the virulence gene expression in the pathogens. Another challenge associated with the biofilm, as referred by Dr. Kidd, is the presence of persistent cells. Persisters are populations of antibiotic-tolerant bacterial cells that are often slow-growing or growth-arrested. The presence of persistent cells contributes to the recalcitrance and relapse of persistent bacterial infection. It also increases the risk of antimicrobial resistance in biofilms. Horizontal gene transfer can also facilitate the spread of resistance. Tackling AMR is crucial in achieving universal health coverage. So these are some of the problems we address. A complex microbial interaction, there is still a lot to understand. How do they interact and how do they adapt? Upon every challenge, when we discover the mechanism, by the time the bacteria or the microbes would have adapted to a new strategy. So detection of biofilms is crucial. Complicated antibiotic treatment is also very important, and we have to focus on both the pharmacokinetics and dynamics of antibiotics in this task. So the climate change and the AMR, I'll take one more minute, madam, if you permit. The climate change and the AMR is also influencing or fueling the problem of antimicrobial resistance. For instance, the increased human activities, the COVID-19 pandemic, the heavy rainfall, all can transfer the resistant forms to different parts of the world. And the overuse and misuse of antibiotics in agriculture, aquaculture, and in animal husbandry, fueled by global warming. It is estimated that for every 1 degree increase, some 2 to 5% increase in the antibiotic resistance within the population, they have been reported. The changing trends of climate change and the pollution fuel this problem. Right? Though it is seemed to be clumsy, adapted from Weldon et al.'s report, where a Paris Climate Agreement with existing global AMR efforts have been discussed. So some of the promising approaches in the detection of biofilms are using molecular methods, advanced microscopy techniques, spectroscopic methods, and novel approaches like FISH, all the expansion microscopy, ion flow tube mass spectroscopy, all these can help us to detect biofilms. So the routine microbiological laboratory tests like microplate method or tube method will not be able to detect the biofilms inside. So these strategies will help us in detecting biofilm detection. The therapeutic strategies for biofilm-mediated infections involves a lot of opportunities, and they are more in research and in clinical trials. So we have to discover new antibiotics. A lot of investigations are being done or carried out in these areas. Combination antibiotic therapeutic strategies, use of natural products, use of antimicrobial peptides coupled with nanomaterials, non-steroidal anti-inflammatory drugs, and other promising strategies to deliver the drug using nanoparticles are currently under research. So to conclude, the understanding, the diagnosis, the treatment and management of biofilm-mediated infection is crucial. And the antimicrobial stewardship, improved surveillance systems as addressed by Dr. Geeta is very important. The One Health approach, a joint plan action is adopted by the joint initiatives of the FAO, the UN Environment Program. It's an integrated approach that aims to sustainably balance and optimize the health of the people. So let us all unite and work towards a better tomorrow and a better future. Thank you for this opportunity.
Thank you, Dr. Gayatri, for your presentation. Let's wait until the end of the session for the Q&A session. Now we go to the third speaker, Miss Lalita. Can you show the CV of Miss Lalita, please? Yes, Miss Lalita Ambigai Sivasamukam from Malaysia, Inti, will talk about green medicine exploring plants as antibiotic alternative. The CV of Miss Lalita. Okay. Nowadays is still PhD scholar innovation and technology, microbiology in Inti International University, Malaysia. So many work experience from January 2011 to current as a senior lecturer, Life Sciences Division from Faculty of Health and Life Sciences Inti International University. Miss Lalita, the floor is yours.
Check, check, check. Thank you. Thank you, Dr. Donna. I would like to also extend my gratitude to the organizing committee, specifically also to Prof. Geeta, who kind of twisted my arm to attend the talk because the time was just not on my side. Over there, it shows that I'm a PhD scholar. I am humbled to mention that the PhD thesis has been submitted just in time when she was twisting my arm. So I stand before you, humbled to share my insight, thank you, on the use of plant extracts as alternatives to antibiotics. Now, we have seen and heard a lot of statistics concerning the problem that we are facing. And you are in the front line as doctors, and you have your bit to play, right? And before I start off with my presentation, let me give you a little story of what also inspired me to share this with you. Now, in my hand is a strip of lozenges, which is often prescribed by doctors to treat sore throats. Now, most of the sore throats are caused by bacterial infection. Now, a couple of weeks back, I suffered from mild sore throat. And being a person who's always on the go, I didn't like the thought of being sick. I'm sure a lot of y'all are there because there's so much to be done and covered. So when I went to visit the doctor, he prescribed me a number of medication, and he also wanted to prescribe antibiotics, to which I said no. Being a microbiologist, I know the extensiveness of the infection. So I told him, please wait. If it does not go away in 3 days' time, I'll come back. See, a layman will not have that knowledge to say no. So he could have just persuaded me to take further, but I said, no, I'll wait. So he gave me those treatments, including these lozenges. Now, what's in the front cover on the lozenges? Can you please share the slide? Yeah. The prescription stickers was stuck onto it. So since the throat was paining, I had to take it. So although very skeptical, because I have had experiences with lozenges and they're not too kind to my throat nor to the throat or the tongue, sorry. So after taking it, immediately the sore throat resided and I felt very relieved. So I was very thankful, and I just did one more thing. Next slides, please. I just turned to the back and read the ingredient, and much to my pleasure and joy, they are all filled with a number of combination of plant extracts, some of which we are all very familiar with, including ginger. So I was like jumping out of my seat and say, hey, this worked, and it's kind of on my throat, it's not cutting and everything, and it reduced the sore throat. Now, I'm sure most of us would have experience with this, which brings us to the topic of using plants as an alternative to antibiotics. Next slides, please. Now, use of plants to treat diseases, including the one that are caused by bacteriosa, is nothing new to all of us. Now, if you look at this particular statistics, which is from a very recent paper, this is a global distribution of utilized plants. So you can see a number of research being done in the Asian region, as well as certain parts of the other parts of the countries, other parts of the earth, where they are also researching actively in the use of plants because plants are able to treat diseases. Next slide, please. To me and to many of us, plants are nature's gift to treat diseases, and they have been used since ancient time. And they are still in use. And reports tell us that 70 to 95% of the global population still rely on the use of plant extracts in treatment. And if we are wondering why is that so, I'm going to give you a couple of reasons as a take-home messages for you. Number one, plants have phytochemicals. Next slide, please. Now, these phytochemicals are often known as secondary metabolites, which plants naturally produce in response to stress. That could be bacterial infection, any other stress that they are going through in the environment. And there are many classes of these chemicals, which includes the alkaloids, the sterols, the phenols, the terpenoids, and many more. And within each of these big set of chemicals, you have many subsets or specific phytochemicals that you would find in the particular plant extract. So if you're wondering what kind of plant and which plant parts can we use, it can be numerous, ranging from the leaves, and I'm so happy to see a number of fresh flowers here. If you ask me, I was sitting there and I was watching and I said, that looks very interesting. I would just pluck it out and wash it, dry it, and do what we usually do in the lab, and I will share with you in a bit of what we do. So they naturally produce this compound. The specificity of this compound will differ in different plants and which part of the plants that you are using to treat or extract for treatment purposes. Next slide, please. So here is what we want to see. Thank you very much. This is something that we have to see. This is nothing of what my fellow researchers who have shared earlier, but this is to show what the plants or the phytochemicals can do. Remember, there are many resistance factors that we have seen earlier, the efflux pump, the disruption in the plasma membrane, and so. Now, what the phytochemicals can do is, for instance, stop the pumping of antibiotics. So if you stop the pumping of the antibiotics that has already gone in, antibiotics have time to finish up its job, it will be able to kill the bacteria. So what some of the research that they are doing is they're combining plant extract with antibiotics. So what does it do? It reduces the dependency of antibiotics. So you're reducing onto that and you're combining that with the plant extract so you have better efficacy to treat the infection. This is one way as to how you do it. And then also, it also promotes, another example is it promotes cell membrane disruption, which means it lyses or reduces the rigidity of the plasma membrane. And we know as any living cell, the moment the plasma membrane lyses, they are very prone for cell death. So once that happens, the cell becomes very vulnerable and able to undergo death. Next slide, please. The next reason. So the first reason is they have phytochemicals, very diverse, right? And they have antibacterial property. The next reason is they exhibit synergism. I know you have heard a lot of these terms throughout the day, and it can be a bit difficult since you're seated for the whole of this session and it's been a couple of hours. Synergism is, to put it very simple, is when you use more than one compound, the activity is heightened to destroy the bacterial cell, one that you do not see with antibiotics. Antibiotics, single target, single mechanism. Plants, multiple target, and they do it collectively, which is simply like you work collaboratively and you get the work done more efficiently. So this, you see it in plants, one that you do not see in antibiotics. And it's just not for antibacterial activity. It can be for even anti-cancer, anti-inflammatory, even anti-biofilm activity, like the one that Prof. Gayatri was mentioning just a moment ago. Next slide, please. Number 3, they have this that you will not find in antibiotics. So you have all the reasons to take back today. Number 3, they have resistance modifying agents, which means you may be wondering, hey, miss, will there be possibilities of resistance, emergence of resistance among the bacterial population against the plant extract? I have an answer for that. No, not likely. You know why? Because you have multiple phytochemicals. So which one is the bacteria going to target? It's not that easy for them to develop. Thus far, they have not found bacteria that have gone resistant to plant extract. So we have a very promising candidate as an alternative to antibiotic resistance. Next slide, please. Yes, they do not exhibit side effects in consumers, but I would like to add in here. So long that the testing has been done clinically approved, like the one that I have just showed you about the Tracizil lozenges. Unfortunately, if you're suffering from sore throat right now, I did not bring any of it. If not, I would gladly give one to you, right? So like I was saying, as long as it's tested, the concentration is known, there are no reported toxicity, then it is safe and you do not see these side effects, which is often seen in individuals taking antibiotics, feeling nauseous, disruption in your microbiota, in the gut, diarrhea, and so. Next slide, please. Because of so much of evidence that are being found now, the global population are working towards active research in medicinal plant, and we are humbled to say that we are also part of this team because we are from the region of Asia, where we are also actively, and that's one of it. One of the reason is this part of the world is also rich with biodiversity, which means you have a number of indigenous plants to commonly found plant species. Next slide, please. Okay, that brings me to the next part of the talk, which is what do you do in INTI? What kind of plants do you work with? How successful has it been? Remember, ours is research-based, and we are moving towards clinical approaches. We are there, but I would like to share with you what we do here at INTI. So basically, we test the plant extracts against two types of bacterial groups. One is non-clinical, which means something that you can obtain from the environment. Probably from the elevators, and then probably from the ATM machines. Those are high-touch surfaces from the environment, non-clinical. And then clinical isolates, in which we are working, and we are in collaboration with one of the government hospital in Malaysia. So we get the clinical samples. So we have that, we culture, and we use the pure cultures and test these plant extracts with. Now, like I mentioned, those plants that we have worked thus far includes the curry leaves. Those are not indigenous plants, they're commonly found, so it's not very difficult, and they are not the threatened species, endangered species and stuff. So we have like curry leaves, neem leaves, the curcuma, and many more. So once we obtain the plants, we dry them, we grind them, we sieve them, we store them, and we extract the plant. And we use the solvents such as ethanol, and so we extract the phytochemicals, we concentrate them, and we test for the phytochemicals that are present. If you remember, plants are effective because they have the phytochemicals in them. So we want to know what group of phytochemicals there are there, and that will allow us to anticipate, yes, it's going to be effective against this particular bacterial cell, and so. And this will be followed with a very important test, which is the agar-well diffusion assay. Now, if I may ask the technical team to enlarge this particular diagram. Are you able to do that, technical team? Sorry, technical team, are you able to magnify this? This one, this side. Fantastic, thank you so much. Highly appreciative of your work. Okay, this is a very important one, thank you. Now what we do here is, we grow the bacteria of a known culture, and then we make holes on it, and we insert this plant extract concentrations into each of these wells. So after that, we incubate them along with two important controls. One, negative, which is non-inhibitory. Two, positive control, which is basically the antibiotics. So we put them, incubate them, and then a couple of days later, depending on the species of bacteria, we come back and we look into the zones of inhibition. Zones of inhibition, like Dr. Stephen mentioned, will be where you do not see bacteria to be growing. So that tells you the efficacy of the antibiotics. Here, it tells us the efficacy of the plant extract. So what do you see? If this is the positive control, and this is my plant extract, and that's a zone of inhibition, what does that tell you? Question time. I don't have my students here, so I have you as my students. You tell me what's the answer. Anyone? Are we looking into a sensitive strain, or is it a resistant strain? I want to know if you were listening to the talk since morning. Volunteer? Tak ada orang. Boleh lah, try. Resistant ke sensitive? Ada? If not, I'll get Dr. Donna to pick anyone. Dr. Donna, I leave it to you. Now we
Please want to answer.
Come on. Now we truly know who was listening and who were not listening. Okay, thank you, Dr. Donna. Is this resistant or is it sensitive? Tak apa, tak.
I think it's sensitive.
Okay. Anyone else? Thank you so much for trying. Anyone else? Is this resistant or sensitive to the antibiotics? Okay, I hear a lot of this sound. It is resistant. Very good. Give a clap for yourself. You were listening. Yes, thank you. Now we are a bit more assured. Okay. Now it is resistant. Now I want to show you, although it is resistant to the antibiotics, it is not resistant to the plant extract. Now that's a good news. And we continuously see this when we use plant extract. Now, if I were to change this picture and show you the sensitive strain, antibiotics are more efficient in the sense that there are bigger zones of inhibition, whereas there are smaller zones of inhibition in most of the cases. But the thing is, we are talking today is about antibiotic resistant. Where is our hope? So here we do have a hope. Plant cells, plants. Next slide, please. So I want to share with you some of the work that we have done progressively throughout a couple of years. Right, so over here we tested with the neem leaves and also the, what's this, bitter gourd, right? So bitter gourd, I'm not sure what you call them in Indonesia, Dr. Dona. Peria, in Bahasa is pahit, okay, right. So we prepare, yeah. So if you're wondering, hey, that's something pare. Oh, something that we consume, and I'm sure that so many of us do not like it because of its bitter taste, but we use even that to do that. So what we have seen is, we have used dried leaves of neems, dried fruit, of this bitter gourd, and when we even combine them, and of course, like I've mentioned to you, we see them against the exhibiting antibacterial activity against as marcescens, as epidermidis, subtilis, C. acnes, even as aureus. Next, please. This one here is using lemongrass. So we have tested them against a number of bacterial cells, gram-positive and gram-negative. You would have heard that we have issues with the gram-negative as shared by Dr. Anis, Prof. Anis earlier on. So we have some good news to share with her as well. So what we found out is the essential oil of the lemongrass. Lemongrass is very commonly available as well. So we found that the essential oil seemed to exhibit higher antibacterial activity towards a number of these gram-positive bacteria compared to its leaf and its root. So what you see is same plant but different extracts. So you can see the efficacy differences. So it gives us an idea about which parts you can use and the extraction type itself. And also to the gram-negative bacteria also. If you were listening just now, there were talk about the Pseudomonas aeruginosa, which is a problem in hospitals. And being doctors and future doctors, you're definitely going to be facing this. So we have a promising result of using the extract of the lemongrass to target Pseudomonas aeruginosa. Next slide, please. So this one here is using curcuma and then also the green mung beans, right? We have used them single, and we also have used them in combination to see if there are any increased synergism between the combination of the plant extracts or just a single extract will work. So we had mixtures of results. In some cases, yes, some cases, no. It depends on the susceptibility of the bacteria towards those plant extracts and also other factors, including antagonistic reactions between the phytochemicals, which is also been reported when you use combinations of plant extracts. Next slide, please. Right, so here we have with banana leaves, so 3 types of banana leaves, and then we tested them against MRSA, and also the sensitive strains of S. aureus. So what we see here is, so here we have included clindamycin as a positive control. So through the ANOVA analysis, what we see is there is no significant differences between the clindamycin, which is the antibiotic, and the extract. So it tells us one thing: the effect is more or less similar to the antibiotics itself, which means if I were to further research this and test them further, I may have a promising candidate to treat MRSA-based infections. Next slide, please. Here we have tested the fenugreek seeds. Fenugreek, Dr. Dona, fenugreek seeds. What do you say in Indonesia? It's commonly used in a lot of this Indian cooking, especially in fish curry, widely available in Asian region. Okay, while Dr. Dona looks for it, so what we did is we extracted different parts, it's the seed, but we used different types of extract. So we have essential oil, the ethanolic extract, and then we even boil them up. So what we found out that the boiled aqueous preparation seemed to have a better inhibition compared to all the zeros that you see, non-effective. So what it tells you here is different preparation of extracts help to extract the phytochemicals and have a better antibacterial activity. Right, next slide please. Okay, so many promising results, and this is only what we do in the lab. So if you go and browse through, you'll find even more interesting amount of details. And I believe through my reading, I've seen a number of research that is also being done in Indonesia, mainly because of the different types of plants that are also available here. Now, the question is, are we there yet? Thank you. I've got a student who's happily nodding, so thank you for listening. Okay, may I have the next slide, please? Good news is, just like the Trazodone, we have clinically approved and safe antibacterial agents. But, next slide, we need concerted effort to continuously work in improving all this data that we have collected. Number one, we need to have an effective extraction techniques. There are several extraction techniques that are generally used in the laboratories. Different laboratories adapt to different techniques, mainly because of the phytochemicals that are extracted, and then also the purification of the plant extracts to ensure that you don't have impurities that can come from the extracts itself. And then generally we see this happening, and you would have seen it in a lot of our data as well. Gram negatives are generally a bit more resistant towards the plant extract. They can be inhibited, but their susceptibility is reduced, as it with what we usually see with the antibiotics as well. So we want to target a range of bacteria, not just gram-positive, but a number of bacteria, including the resistant species. So we need to look for those plant sources that can effectively do that. Then, of course, right now, the current trend of using the plant extract is we want to know exactly what compound in that plant that can exhibit the antibacterial activity. I don't want fuzzy. So right now what I see here is a combination of all extracts. But I'm just intrigued to find out, hey, what is it exactly in each of these extracts that have worked so well to help me in the sore throat? So we want to know the structure, the mechanism. So this is where we are heading with Prof. Gita and other collaborators. We are heading towards that next step. We have known the inhibition, but we want to know what is it exactly in those extracts that leads to the inhibition. Right, and then of course, one more step that we are also doing is to look into the dosage. Anything that's good taken in high quantity will certainly be harmful, right? So we need to test that. So that's why you need further steps to see the toxicity level, how much is permissible to be taken up. If it's for a skin application, how effective is it going to be on top of being safe on topical application. Is it going to be safe? So we need to do all those cell culture testing itself. So there are a couple of steps that you need to take before it is commercialized and declared safe for use. Next slide, please. And then there will be
Excuse me, Ms. Lalita, 5 minutes.
Thank you. There will be variation in the batch of production, species to species. So phytochemicals, you need to study them, the content and so, which perfectly brings me to the last slide. Right, so while we will never cease to face antibiotic resistance, it's not going to go away. And like what Prof. Kita correctly put earlier, the research for new antibiotics is no longer there. So we need alternatives. Plant extracts are one. And another alternative mentioned by Dr. Stephen Kidd was the use of nanoparticles, which are also pretty promising. So we can continue researching medicinal plants and work towards developing global policies nationwide, coming up with policies that promotes the research of plant extracts towards combating antibiotic resistance. With that, I come to a conclusion of this talk, and I would like to, next slide please, extend my acknowledgement to those are all our students' work, which we have worked together. So we would like to extend gratitude to our previous final year project students, undergraduate students, of course my research collaborators, superiors, Prof. Dr. Wong, Ling Xing, and the entire faculty of Health and Life Sciences in Inti International University, and also the university for providing us the grants to complete this research and keep providing us with the grants to proceed further with the research activities. So with that, I hope the last slides can be projected. There's one more slide, I think. Yeah. Maximize that, please. Before that. No. The thank you slide. Yes. If you can maximize this, I hope they become a terror to the antibiotic-resistant bacteria and they run away. I generally do not include cartoon, but I believe pictures speak louder than words. So yeah, we have it here. With that, I thank you, and thank you for listening. Off to you, Dr. Do.
Okay, Ms. Lalita, just take a seat in front. We continue with the Q&A session. Just directly go to the Zoom, the question from the Zoom. For Dr. Kidd, are you still online, Dr. Kidd?
Yes, I am.
Yes. From Prof. Agus Syarul Rahman, does critically ill patient induce antibiotic tolerance? And what antibiotics has highest capacity to cope microenvironmental stress at the site of infection? Can you hear me clearly?
Yeah.
Is it clear? Yes.
Yep. Yeah. Okay. So, the acute infections are predominantly caused by the actively growing cells. So, let's say you've got 100 cells infecting human tissue, causing an immune response and a host cell response. That's what's causing, acute infection. So they will dominate the population of cells that are present in that infection. So when I say they, I mean the actively growing bacterial cells. And when there's treatment, you'll limit those cells. So there has been some really spectacular work actually from a group in Boston in the United States. They're able to track the number of persister cells or the small colony variants, and they are still present, but because they're not growing very much, they're not going to be there in high numbers during acute infection. But then you get rid of all the actively growing ones, and those slow growing cells then have an ability to start to grow. I think I think that does answer the question, hopefully.
Thank you, Dr. Kit, for your answer. We continue for another question, also from Prof. Agus, also to Dr. Kit. Related to the high diversity of cell types at infected site, what antimicrobial susceptibility testing is recommended? What is your opinion on combining surfactant to antibiotic to biofilm infection? And what is your opinion on using bacterial metabolome or synthetic peptide to increase antibiotic activity?
Right, okay, there's a lot of questions there. In terms of, I think the first one was around the detection of, and it's at once again, it's kind of at a site of infection, there's going to be a dominant cell type because those bacteria are actively growing and causing an infection. So it's going to be hard to detect the ones that are hidden. There might be only, 10 in 10 to the 4 cells. So there's very low numbers of bacteria that are there, but there are a lot of people doing some really neat stuff. Indeed, we're trying to see whether we can use digital droplet PCR, so different ways of using molecular techniques. There's some people who are doing really neat stuff to look at using optics to see whether you can track the amount of ATP within a cell. So there are diagnostic tools to look and see whether you can find the viable cells that are non-culturable. So, yeah. And the other thing I should point out is sometimes traditional PCR techniques, because the number of bacteria for these slow-growing bacteria are so small, they don't work. So the PCR will not work. And the other real challenge is that the small colony variants, for instance, that we found actually got inside bone cells, osteocytes or osteoblasts. So the diagnostic tools need to be able to get inside those cells somehow, or use some kind of biomarker as a detection tool. So that's the really important thing. And then the other questions, one of those was a little bit more around biofilm, and perhaps that's better answered by other people. But yeah, I think the other thing is exactly like Lolita commented on, is using combinations and perhaps duration of time so that we can actually target the very low growing bacterial cells would potentially be something to investigate.
Okay, thank you for your answer. Still for Dr. Stephen from Novi Wijaya, I would like to asking about the role of microbiome. Is there any role losing microbiome can cause pathogen bacteria become more infective and related to resistance of antibiotics?
Yeah, that's a wonderful question, and it's actually something in a separate project that we've got going. Patients with diabetes, when they get a diabetic foot infection, it predominantly comes from their own bacteria that they're carrying. So patients who are carrying Staphylococcus aureus in their nose or on their skin are more likely to get an infection in the foot by Staphylococcus aureus. That bacteria can transit around the body. So that's a really important point, because it used to be that doctors or the general idea was that the infection would come from outside. If we clean the hospitals, if visitors into a hospital or nurses and doctors were very clean, they'd stop an infection from outside a patient getting inside. But actually, what we now kind of appreciate, and myself and others have done work to show this, is that the nature of the microbiome within a site of colonization can put pressure on Staphylococcus aureus so that it can actually get around the body. So there are secondary metabolites and there are bioactive compounds that some bacteria use when they're growing normally as part of the natural flora in the nose and the skin or on the gut. And if Staphylococcus aureus is trying to adapt to those because of the nature of that microbiome, Staphylococcus aureus will switch its lifestyle so that it will then go around the body. So I think the microbiome is actually a really, really important thing. It's, one of the things I mentioned was that bacteria need to adapt to the physical and chemical stresses that the host cell throws at them, but also the biological stresses that the neighboring bacteria are throwing at Staphylococcus aureus as it colonizes.
Okay, thank you. Also from Dr. Simon, for the Dr. Kit also, in post-amputation patients who are found to be CVV Staphylococcus aureus, can decolonization using chlorhexidine reduce the risk of recurrent infection by SCV Staphylococcus aureus? Thank you.
Yeah, one of the real problems with a lot of antibiotics is, well, the simple answer is we used to think exactly that. We could kind of use specific targeting by antibiotics or antimicrobials after surgery, and that does work. That works quite a lot. But in those cases that relapse, our evidence is that the bacteria have been able to hide, and once again, inside host cells. So the antibiotics have limited efficacy against these healthy bacterial cells that sit within a bone cell, for instance. And we also know, I should say, that the lung epithelial cells, there are other human cells that Staph aureus, for instance, can switch its lifestyle, so switch into a small colony variant or an L-form bacteria, and then get inside the human cell, and then they're kind of avoiding, some antibiotics can get in, but not work very well against the bacteria.
Okay, thank you, Dr. Kit. And then from Dr. Samekto, izin bertanya, is there resistance is stay forever?
Yeah, so with those, with small colony variants, it actually becomes a little bit complicated. We've had samples that we've got from the hospital where the small colony variant will rapidly revert and will change from being kind of tolerant to susceptible. But as it does that, it becomes more virulent, so it switches on a lot of the virulence factors, and that can happen quite quickly. While we've had others that will stay in a very, very slow growing state, and when we do some cell biology, they're not very virulent, but they remain antibiotic tolerant almost consistently. So they're stable small colony variants, and then you have unstable small colony variants. But we like to kind of put names on things and describe things as humans, but biology kind of does things in a very haphazard and random kind of way, and it's hard to, so we get little versions of small colony variants that are both stable and they'll remain stable and antibiotic tolerant, but others that kind of, switch back to being susceptible after a couple of generations.
Okay, thank you, Dr. Kit. We move to another speaker question for Dr. Prof. Gayatri. Permission to ask regarding biofilm. Can the presence of biofilm trigger an immune reaction by recognizing it as a foreign body? Prof. Gayatri, you still with us?
Yes.
Okay.
It's an interesting question. Yes, our body, our immune system recognizes not only bacterial cell as a foreign organism or an antigen, but even biofilms. We know that biofilms, the organisms, microbial cells within the biofilms produce lots of extracellular substances, the EPS, the QS molecules, the eDNA. All these are recognized as foreign bodies only. So both innate and acquired immune systems can be triggered against biofilms. But how successful they are, that remains the question. In a monospecies biofilm, when a planktonic cell disrupts from the biofilm community, and when it comes out, it is easily destroyed because they exhibit the PRR, the pathogen recognition patterns. Okay, so these recognized by our toll-like receptors and other components of our innate immune system, they can recognize and target. But when the same cell enters within a biofilm, then it is going to be challenging for our immune system. However, the other component of an immune system, we have a strong polymorphonuclear leukocytes. They produce a lot of antimicrobial peptides. For example, neutrophils produces defenses. So these sort of molecules may penetrate the extracellular matrix or the polymeric substance, EPS. They can target the biofilm as such. Sometimes, if the innate immune response is not successful, the adaptive immune response can take over. So antibodies have found to be useful, but it is not successful. And the mechanisms of immune response against monomicrobial and polymicrobial biofilms, they differ. And they not only differ between these, they differ with different organisms also. So more research insights has to be looked into, where how these immune mechanisms actually, whether they are successful or not. But generally, these biofilms are recognized by our immune system.
Okay,
Hope
thank
this
you.
has answered the query.
Yes, thank you, Prof. Gayatri. Another question from Prof. Agus Yarur Rahman. What chemical is safe and highly active to disrupt matrix of biofilm to allow antibiotic penetrate and contact with the bacteria inside biofilm as to superficial and deep infections? Is it clear?
Yeah, I can understand the question. Whatever compounds we are synthesizing, we have to look for the toxicity. So our aim is not only to destroy the microbial cell or the biofilm, how it happens in vivo. So most of the studies that are carried out in vitro may not be successful in vivo. In clinical trials, they may fail. So there are a lot of strategies that are being adopted. That's what when I was giving my lecture, I addressed this challenge. The strategies are there. How far they are successful is still in question. We have lots of promising strategies that are applied and proven to be even successful. Just now we saw Dr. Geeta's scholar who was presenting about the natural products against antimicrobial resistant organisms. So combination therapy is a good strategy. So curcumin loaded nanoparticle approach is also being analyzed, and they've proved to be promising also. There are certain specific strategies to disrupt the biofilm structures. For example, we have efflux pump inhibitors. A recent report suggested a molecule, a phenylalanine, arginine, beta-lactylamide, I presume. So this has found to be a successful inhibitor of the efflux pumps. When coupled with antibiotic, it has been proven to be disrupting the biofilms formed by Staphylococcus aureus, Pseudomonas aeruginosa. We also have strategies adopting the use of antimicrobial peptides in combination with antibiotics that have already been proven to be safe. So this might increase the ability of the antibiotics to destroy the biofilm producing organisms or even to kill the organisms. We also have other compounds that may be useful, predominantly from the plant products.
Okay, thank you, Prof. And then also there is a question, is antibiotic that already resistant for 10 or 20 years is still resistant for the same disease?
Sorry, the second part of the question I don't understand.
Is the antibiotic that already resistant for 10 or 20 years for the infection is still resistant for the same disease or infection?
It's a tricky question. we cannot say for sure. So the antibiotic resistance exhibited by bacteria at certain point of time. Usually the genes may be transferred to the generations. It may be there. Yeah, it may be present. The only strategy is to analyze it, to see how we are going to destroy that, how we can prevent the spread of antibiotic resistance. I think I can get opinion from Dr. Stephen Kidd. What is your opinion, sir?
Yeah, no, and it is interesting. There's a fitness or energy cost to harboring genes that are not required. So there have been studies where people have looked at antibiotic resistance in an infection, and then the numbers will decrease. The number of bacteria will decrease when the antibiotics are used, and then it sits there. There's no disease. It's low enough bacterial numbers. So there's no antibiotics being used. And actually what will happen is, because there's a little bit of a fitness cost, it's hard for the bacteria to hold all those genes if it doesn't need them. So there's not the selective pressure of the antibiotics being used on the bacteria all the time. So the bacteria can throw those genes out. And so after a period of time, they can be sensitive. But yeah, it is, that's exactly right. It's a little bit of a toss-up, because sometimes the genes can be, like an efflux pump can be useful for the bacteria in different contexts. And it depends on how the bacteria is using those efflux pumps. So that will remain present. So it depends on which antibiotic and which resistance you're talking about.
Okay, thank you for your answer, Dr. Kit and Prof. Gayatri. We move to another question to Ms. Lalita. What indicator is being used to extract plant, since the composition of active ingredient in plant greatly varies, and in depending of age, geography, soil fertility, and etc. It's also a question from Prof. Agus.
Thank you for the question. That's a very, very good question. Now, what factors? In our research lab, we look into the thermostability of the phytochemicals. So when I extract, I'm speaking on my side, and also based on literature, I look into how stable they are. Generally, a lot of these phytochemicals are quite thermostable, so we carefully look into that because we want to retain the phytochemicals. So that, for me, we use that as an indicator to retain the phytochemicals. And we have seen from the reported papers that we have published, our phytochemical extraction, we use the Socklet extraction technique, and we have prescribed time concentration using rotor evaporation, also prescribed time with the right temperature. So it's a very delicate process. So we try to retain most of these phytochemicals, which are basically soluble in this organic solvent, and we carry out the research activity. So that's the main indicator for us. But to answer the second question, he mentioned about the geographical location. Yes, okay. One particular research that we did, getting the plant extracts, of course this is not published yet, but that particular thing was that our collaborator, previous collaborator, she mentioned that there were no significant differences of these plant extracts when they were compared with. However, if it's from different countries, let's say you want to test the plant extracts from Indonesia, maybe like curcuma species. You want to take the ones from here and also from Malaysia, and then we want to test and see. Probably we might see differences. Number one, climate. Two, the soil content. You see, phytochemicals are produced in response to their stress. So what stress? That induces the phytochemicals. So there could be differences in the components that are being produced by the plants in response to the stress, and we may see differences in the antibacterial property. That brings me to the last one, so that it will be a concrete conclusion to his question. In this kind of studies, we are always mindful of the source of the plant extract. So we try to take it from one single source, and cultivated like in a herbarium, so you have a very controlled environment. You try not to pick them up from different environments and try testing, you are definitely going to see differences in the components. So we try to standardize. We are looking into commercializing them. We want to standardize the production of the plant extract. I hope that answered the question.
Yes, thank you. Also from Prof. Agus, since molecular weight, density, and affinity of molecular component to agar, is there any internationally standardized assay on agar diffusion?
For the agar diffusion assay?
Yes.
Okay. There are no, as far as I know, I don't see much of a standard assay as to standard concentration that is required to carry out the agar well diffusion assay. We do not do all those molecular weight of those plants. Remember, we are not working with, for me, I don't work with a specific chemical compound. However, to answer Prof. Agus' question, if I were to extract a particular phytochemicals, like curcumin for instance, then yes, I will need to know the density, the molecular weight, the purity level before I proceed with that. Generally, that would require extensive studies before I go into, before we proceed to obtain those phytochemicals. So if in this case, ours is crude extract, I prefer the entire extract as you have a synergism. So here we don't do that. As long as you can standardize the concentration and follow the guidelines that is provided by CLSI. All our techniques are CLSI based.
Okay, thank you. Last question from Prof. Agus also. When using plant extract, I think we should differentiate it as disinfectant or antimicrobial. Have you ever compared extract activity measured by zone diameter with phenol coefficient, and how was the result?
Coefficient test?
Yes.
No, I did not do. Unfortunately, I won't be able to answer that question. But the disinfectant and
Microbial.
All right. Currently, ours is in that stage. We have not, like I said, it's progressive, so I'm unable to address that question. But thank you for giving us the idea. Yes, I would love to look into disinfectant, something that I can put into sprays or turn it into a hand sanitizer. Safe. Yeah.
Yes. Thank you. Also, for the limited time, maybe another question will be answered directly later by Zoom. This is the last session of the second session of today. Give applause to all our speakers. Maybe we can continue. Giving back to the Master of Ceremony.
Thank you, Dr. Dona. Thank you to our doctors and our moderator. And now, symbolic awarding of certificates to our speakers, Associate Professor Dr. Stephen Kitt, Associate Professor Dr. Gayatri Guru Rajan, continued by giving a certificate to Ms. Lalita Ambigai Siva Samugam that will be given by Dr. Nur Selan Tajudin SPKJ. To Ms. Lalita Ambigai Siva Samugam, Dr. Nur Selan Tajudin SPKJ, please occupy the designated place. And for the Zoom, certificates in the Zoom, are we going to show it? Yes. Okay. To Dr. Gayatri Guru Rajan. Congratulations, Doctor.
Thank you for giving me this opportunity.
Thank you, Doctor. Next one is for Associate Professor Dr. Stephen Kidd. Okay, I think that's all for the certificate awards. This is Dr. Stephen Kidd. Please give a round of big applause for Dr. Stephen Kidd. Okay, thank you. And for now, we're going to take a break for a moment. This seminar will be resumed at 1:20 p.m. Indonesian time. We hope that the participants offline and online will be here before 1:20 p.m. so we could start this seminar on time. And for the audiences that are going to have lunch, you may eat outside the auditorium. And to the online participants, please also join the break room. Please also join back to the Zoom before 1:20 p.m. Indonesian time because the attendance link will be shared to the Zoom to get the certificate for today's seminar. Thank you to everyone. Please enjoy your lunch.
Berawal dari mimpi dan visi kami untuk menjadi universitas entrepreneurial unggul yang
Kepada
memiliki
peserta
integritas
yang
dan
di
profesionalisme
dalam
di
Zoom,
Asia Tenggara. Pada Dies Natalis
mohon agar tetap
ke-64,
join Zoom
Untar sebagai
karena setelah
perguruan tinggi
ini akan
swasta
ada
terkemuka
topik
di Jakarta
yang
meluncurkan slogan baru.
mengkaitkan
Untar
apa yang
untuk
kita dapatkan
Indonesia,
hari ini dengan
Untar untuk
kondisi
dunia.
klinis yang ada
Sebagai
di
wujud
rumah sakit.
komitmen kami mendukung
Kemudian link
pembangunan
absen
nasional
dan link
serta
feedback
berdampak
akan
bagi global.
diberikan pada sesi ketiga untuk peserta yang terlink dengan LMS. Maka akan mendapatkan 2 sertifikat, yaitu sertifikat dari pelataran sehat dan sertifikat internal dari Fakultas Kedokteran Untar. Sementara peserta yang tidak terlink dengan LMS akan mendapatkan
Jejaring. Untar berusaha eksis kancah internasional mulai dari Asia Tenggara, Asia, hingga Eropa. Ratusan perjanjian kerjasama telah ditandatangani Untar bersama institusi luar negeri dan telah diimplementasikan dalam berbagai bentuk kegiatan, seperti pertukaran mahasiswa, pengabdian kepada masyarakat dalam negeri maupun luar negeri, visiting professor, pelatihan dan pendampingan, dan masih banyak lagi yang tentunya mendukung pencapaian indikator kinerja utama perguruan tinggi dan kegiatan Merdeka Belajar Kampus Merdeka.
Untuk mewujudkan misi Untar menjadi perguruan tinggi kelas dunia, Untar membangun kolaborasi dengan berbagai macam perguruan tinggi dari berbagai negara dengan melakukan aktivitas positif yang selalu kami lakukan, seperti pertukaran dosen, pertukaran mahasiswa, penelitian bersama, publikasi bersama, kegiatan pembelajaran bersama, pengabdian masyarakat tingkat internasional, dan berbagai aktivitas lain yang ditujukan untuk membangun reputasi Untar di tingkat internasional. Kami berharap kolaborasi ini betul-betul dapat kita tindak lanjuti dan kita kembangkan pada masa-masa mendatang dengan lebih baik lagi.
For us, right, really appreciate and also learn a lot of things in Indonesia because the things like we not only exchange the program that we learn through in this one week, also exchange the kenangan together with semua.
And I think Indonesia is one of the biggest country in the world, and Untar is one of the famous university in Indonesia. So here I am.
My first semester in the German university, our lecturer mentioned something about it, and I thought, oh, that sounds cool. I think I want to do it. And I was thinking about it, and I was like, yeah, why not? It's a good experience. You learn a lot about culture and people, and it's a really good chance for me. Yes.
And I'm looking forward for the more international cooperations, more entrepreneurship ideals for the future with Indonesia and Taiwan, and we could raise the economics.
This university is so special university, and I want to send my students also join the exchange programs. Some students or related with the staff. We are happy to meet you.
Kolaborasi lintas batas tidak hanya memperkaya pengalaman belajar, tetapi juga menghasilkan pemikiran yang lebih kreatif dan holistik. Inklusi menjadi inti dari ekosistem pendidikan yang inklusif. Melalui kolaborasi yang kuat, Untar berupaya membuka sejuta pintu menuju masa depan yang lebih cerah dan berkelanjutan. Untar untuk Indonesia dan dunia, pendidikan inklusif untuk mendukung pembangunan berkelanjutan.
check.
Happy.
mengantar langkah kecil menuju impian besar yang menjadi kenyataan. 8 fakultas di Universitas Tarumanagara siap mendukung spirit memenangkan masa depan yang semakin ketat. We build today to win the future. Kini, Untar didukung lebih dari 1.000 dosen berkualitas yang turut membentuk pembangunan karakter positif atau Untarian. Menghasilkan generasi pemimpin yang berintegritas, profesional, dan berjiwa wirausaha adalah komitmen kami. The future is yours to define. Universitas Tarumanagara.
Good afternoon and welcome back to our speakers, moderator, and participants offline and online. Let's continue our seminar with the third session with the topics misuse of antibiotics and the impact to the treatment of infectious diseases by Professor Dr. Anshu Agarwal, optimizing antibiotics use in hospital and primary healthcare by Dr. Velma Herwanto, SPPD, PhD Finasim FACP. The third session will also be guided by Dr. Donatila Mano, SPMK, as the moderator. To Dr. Donatila Mano, SPMK, the floor is yours.
Thank you. Now we will start the third session. I am pleased to introduce our expert from the third session, Prof. Dr. Anshu Agarwal from Saudi Arabia. Will be bring the topic of misuse of antibiotics and the impact to the treatment of infectious diseases. And the second expert is Dr. Velma Herwanto, SPPD, PhD, Finasim FACP from Untar. Will bring the topic about optimizing antibiotics use in hospital and primary health care. Prof. Anshu already with us. The CV Prof. Anshu can be seen on the screen. Prof. Anshu, can you hear my sound clearly? We will wait for the connection from Prof. Anshu. Okay, Prof. Anshu. Already with us. Can you hear my sound clearly, Prof. Anshu?
Sorry, yeah, because host has not given me the permission to talk, so I just took a while. Thank you so much. I'm just sharing my screen. It says that only host can share in this meeting. Can you please allow me to share my PowerPoints?
Yes.
Thank you so much.
Thank you, Prof.
Just 1 minute. I'm just taking 1 minute.
Excuse me, Prof. Ansu. We only have PDF version of your slides. Maybe can you send the PPT?
Send you the PPT?
Can you
Hello?
send the PPT?
Yeah, I can, but on what number I can send you the PPT?
To Prof. Gita.
Okay, I'm just sending her my PPT. Thank you, therefore I was struggling, it was not uploading.
Oh, okay. Email to Dr. Shirley.
No, I'm sending it to Dr. Geeta.
Oh,
Is it okay?
Yes.
Yeah, I'm sending it to Dr. Geeta. Yeah, I've sent it to Dr. Geeta. You can just please make it PDF. Yeah, thank you so much. Thank you. Yeah, good afternoon to each and every one of you. And it is for me still, I'm good morning and hope you had a nice lunch. And we are still in the breakfast time. So I welcome you all. I am Dr. Anshu. I am working in Kingdom of Saudi Arabia. Actually, I am a pathologist, but I feel honored to have this opportunity to just give a talk on this antibiotic resistance because it's a pandemic. Each country, everywhere, it has become the matter of concern. So the topic is misuse of antibiotics and the impact to the treatment of infectious diseases. Next slide, please. So, that already so much of it has been spoken on antibiotics. So, all these topics they have already been covered. So, basically, what I'm trying to cover in my talk is we have done so much of research in different countries on different aspects of antibiotic and its resistance. So, mainly, I will be sharing the perception and whatever has been the observation, and it will be covering the objective of the topic I have chosen to share in this webinar. So, just next slide, please. You can just keep on shifting the slides because it will otherwise take time. So we all know what is antibiotics. So, and we know that this antibiotics, it is a actually broader group of antimicrobial compounds and it is used to treat infections and microorganisms, but it is alarming to see that many times people don't even know what really antibiotics is and what is the use of antibiotics, and it is very widely used to treat even fungal infection, protozoa, and even the normal viral or day-to-day common ailments that people suffer from. Next slide, please. Can you please go on shifting fast because I just don't want to stay on these slides. So this word, this antibiotic, it comes from antibiosis, and it is years ago this word was coined. Next slide. May I request who is shifting the slide can go on shifting fast. So this is the history of the antibiotics. So it was already the Dr. Geeta, she has covered the history, but it is that it is a kind of a recap also, and it is just again to remember, right, that it was Alexander Fleming, and in 1920s, while he was working in the St. Mary's Hospital on culture, so that these antibiotics, it was discovered that they can just destroy the bacteria. Next slide. So this is that we know that Alexander Fleming, who has worked on the penicillin, and from where this and even he got the Nobel Prize also. And I request, please, if you can on shifting fast to stay on the side and wait for me, say please, because some slides are only to show, not to speak on that. So this is just to show that he got a Nobel Prize also, and this is in 1945 he got this Nobel Prize, and so it is he he just warned about the danger of this bacteria he just discovered, and from that discovery that antibiotics, so from 1928, like that, after every few years there had been new antibiotics which were discovered against the different bacteria, and it is like it has never not stopped till now. And we see that every year, every now and then, this pharmaceutical industries, they are coming with new antibiotics. Please go on shifting. I just these slides are to show, but I will like to speak on my own. So antibiotics, so they have been considered as one of the biggest advances till date. But what is alarming is, and what is this topic is about, that the unnecessary prescription of antibiotics, like even to treat a little pain or any kind of infection, it has become a concern. And indeed, it is having a negative impact on individual as well as the community health. And so this use of antibiotic, so it is basically these antibiotics is to treat or to prevent the type of bacterial infection. And some antibiotics, they are very, very highly specialized, but some they are effective against certain bacteria. And many times if we go to the doctors, they will just give you the broad spectrum antibiotics. And these antibiotics, which are broad spectrum, they cover the wide range of bacteria on which they act. And some bacteria, they are even beneficial to us. And those bacteria, they are also killed by the use of these broad spectrum antibiotics. And certain bacteria, certain antibiotics, they have a very, very specific role. So therefore, whenever we talk of antibiotics, we talk of antibiotic resistance, we have to keep in our mind, like we have the whole body, like from our flora, from the mouth till the, like any organ you take off, it has got so many beneficial bacteria also. And when we are misusing or overusing these antibiotics, even those bacteria, they are killed. And so this is actually alarming. And from there it came, what is antibiotic abuse and misuse. So overuse it when it is not needed, still people or even the doctors, they are giving antibiotics. And the misuse is when the patient who has been given and he is not completing or he is not compliant. And even it has been seen that people, they had been using the antibiotics which are not prescribed from them. So it is, if they have been just somebody else has taken, they ask from their friends or from the people in the family, and it is being used. So that is what is the difference between overuse or misuse, or we can say abuse. Like it can be considered as antibiotic abuse also. So this is antibiotic so some people, they will call antibiotic misuse as antibiotic abuse. So these terms, they are very, very vaguely used. But what is happening is that it is a contributing factor to the development of antibiotic resistance, including and that is what is happening, that because of this overuse or misuse, that there is a multi-drug resistance bacteria, so which are just coming into existence. And these bacteria, now they are called as superbugs because there is no treatment, because they have become antibiotic resistance. And now the doctors, the hospital, they don't know how to deal with these superbugs. So this is so now I think that all of us, we know, we are just from the morning sessions, we are listening to the antibiotics, antibiotic resistance. So this is what now the matter of concern is, how the misuse of antibiotics is taking place. So I think that even those who are the participants or those who have experience in dealing with the patients, or maybe among your family or friends, so you might have also seen that antibiotics, whenever anybody goes to doctors or hospital these days, very frequently these antibiotics are given, and these patients, they also, they either they go through internet or with their experience or whatever may be the reasons, most of them they are non-compliant and they discontinue these taking the course of the antibiotic, and they will leave in between this course of antibiotic, and which causes the bacteria to survive. And this is the reason that this overuse has become so much harmful, and this is the reason all of us are here and we are just sharing our experiences or trying to create awareness. And in the last decade there has been tremendous splurge in developing microbial resistance, and when an antibiotic is no longer has an effect on the particular bacteria, so they become it becomes very, very difficult to treat this bacteria, and they have just led to so many of the death. And these efficacies of various antibiotics, therefore they have become a threat, and it has reached a pandemic stage today, and this is a matter of serious concern to each one of us. So all of us know that the antibiotics where they are commonly used are like it may be needed, it may not be needed, but as soon as somebody is diagnosed with acute bronchitis, even with common cold or UTI, so these antibiotics are frequently given. But initially it was a use of antibiotics, it was found to be useful in tuberculosis and leprosy-like conditions, but these are also in these chronic diseases also it has been noticed that antibiotics have been used irrelevantly where it was not needed, or if it was not properly diagnosed and all. So many deaths they have taken place because of misuse or overuse of antibiotics, even in the chronic conditions like tuberculosis and leprosy. So this overuse of antibiotics, even when they are not, when it is not even an appropriate treatment, and even according to the Center for the Disease Control and Prevention, that from one third to one half of the antibiotic use in human being, it is unnecessary. So therefore we have to keep in our mind that from now, like we have just seen the statistics through certain journals, and we have seen from between 2000 to 2015, this misuse of not even antibiotics, but most of the medicines, the misuse is increasing. So even when we just try to do a survey in different countries, and this was just the conclusion, the abstract of it was that even it was found that the farmers in the food industries also, that the antibiotic use or overuse or misuse was found to be too much, and even they are being given the warnings. And even we just try to find out how many health authorities, they are just trying to do some preventive measures about it, and it was found that though it is so many awareness programs they have been by different countries, by different organizations, they are implemented, that through vaccination, by improving the basic hygiene, certain infections can be prevented. But it was found that even these certain things which we see, which we just assume that these programs are taking place, but we just, according to our surveys, according to when we just try to do some kind of research projects, we found that even certain basic things, they are not in place in not in many countries, I should say. And even the broad spectrum antibiotics, it was found that it was just given for very, very irrelevant diseases also. So the misuse of antibiotics, it is the main reason which has caused the development of resistance. And the antibiotic, the drug which was used to kill the bacteria, has now started killing the human beings. So the main thing is we just try to do certain surveys also, and try to create an awareness program also. And those who are listening, those who are participating in these type of survey programs, so the main message that should go to is antibiotics will never stop cold and flu recovery, and especially after this COVID-19. it has become so much common. Even during COVID days, if you remember, that everyone was very frequently, they were just given this antibiotics, and people they had this kind of misconception or myth that these antibiotics, they have got a great role even in just dealing with the dangerous infection like in this COVID-19 also. And these other common viral infections that in which there is no benefit from the antibiotic treatment, and like if you just do any kind of survey or if you go to any hospital, you will find that even for the small thing, like even for a little cough or some small sinus or ear infection also, these type of antibiotics, they are so much in use. Even for the second and third generation antibiotics, they are very commonly given for the infections in which these antibiotics are not needed. So what can be done about it? So number one is, nowadays it is very common, it has become very common, that is self-medication, and we need to stop this self-medication, because nowadays very commonly even people, they have lost trust in the hospitals or the doctors, and they just go to the Google and they just take it. They don't understand the difference between a Panadol or a antibiotic, and they don't know which drug can control what type of infection. So it was found that 1 in 3 patients in the hospital, even in countries like England, they had been on antibiotic at any one time, and even 1 in 3 individual, they take at least 1 course of antibiotics each year. So we can just see that how much misuse or overuse of antibiotic is taking place. So we can just say that there is an inappropriate use, and especially on the infections, just like viral infections, just like a common cold, even for the sore throat, you will see that all kind of people, like whether they are educated or uneducated, or they are even, if we see like in the hospital setup also, you will find that inappropriate use of antibiotic is going on, even for the simple conditions like common cold or a flu or some viral infections. So what are the reasons for antibiotic misuse? So they say one is the over-the-counter availability of antibiotic without the prescription has been one of the most important factor which contribute to the public behavior towards overconsumption. So many countries, especially the developing countries, it is found that there is like just as we go to the counter, we can buy the antibiotics, and just they Google it and they go and they take it without even knowing that whether it is of any use or not. So this shows the statistics of one of the survey which was done, and it was very alarming to see that people, they have got, like if they go to the hospital because of maybe like this kind of awareness program, it has got some kind of a different impact also, and that different impacts are that people, because they just hear it and they cannot just know, like it is said that little knowledge is a dangerous thing. So the prescriptions which were given to them, so when we did the survey, we found that in the prescription 2.8% of the people, they were not even sure why this antibiotic prescription has been given to them. And some of the people, it was alarming to see that they were not even, they just kept it, and they thought that if their infection will become worse and then they can take it, or some people, they just stopped it in between. So it is not that when we just talk about antibiotic misuse and overuse, it is that people are just taking it for the infections or the conditions where it is not needed. But when the survey was done, it was alarming to see that people, when they just read many information from the newspaper, or they hear in the news or from other social media, so they have got different myth about it, or they have just made like their own assumptions, like when to use, how to use, where to use, which has just taken a very dangerous turn. And they say that it has been noted that if the patient feel better before the course is completed, so in many surveys in many countries, it was found that the patient, they stop taking the consumption of the antibiotic, and that is why it has happened that it has even costed many lives. It has costed the recurrence of the infection. It has caused the it has made their stay in the hospital for a very long time, and this is the another reason that this hospital acquired infection, because of bacterial resistance because of inappropriate use of antibiotic is on high rise. And this is like, we did this survey in many countries, in many places, and we found that it was commonly happening in everywhere. It was no place or no country was exemption from it. So, and this was something which is like, because I'm just trying to show you, taking you through the slides where like it is mainly again a conclusion or abstract of certain surveys we done. So this was very, very interesting to see that many countries, many people, even in the hospital, even those who were the health profession people who know about antibiotic, they had been using antibiotic even for the viral infection. And just I would like to say here that sometimes it is not wrong, because when we just talk about bacterial resistance or antibiotic misuse or overuse, we need to remember that certain patients, they are having less immunity. They may be cancer patient, they may be diabetic patient. So even if they have got a viral infection, so sometimes they need antibiotics so that they don't get superimposed bacterial infections. So actually, when we just try to create certain awareness program, or when we try to do certain surveys, we just find, like, we just try to see like a statistics, like, that this antibiotic was given, this was given, that, but we forget that in certain set of people, in certain diseases, it is very important also. So we should not forget about certain other aspects where even in the viral infection or certain diseases, these antibiotics are needed. It is not to treat those conditions, but to prevent the superimposed infection. So just next. So only that here, the message that when we just did certain researches, we only gave one message to all, because we just found that even the statistics was from 65 to 75% this in the countries and in the places we saw that these antibiotics were taken for cold or viral infection. So the message given was that whenever it is given for any cold or viral infection or certain diseases, please just go to the doctor and make sure that this antibiotic, even if it cannot cure your cold or viral or certain diseases, but it is needed because you may have a less immunity. And this is another cause. It is found that in certain countries, like these antibiotics, they are maybe of a low quality, or maybe thing happened. Okay, I will just continue with my talk. So this is what we have. Just please just keep moving the slides first. So just keep moving. So this is a so now we know the reason why this multi-drug resistance it has been developing. So like all the presentations, they just tell you only that one information, the one message is that it is the misuse and overuse of antibiotic for various reasons, where in certain conditions where the antibiotics were not needed, the bacteria, they are changing and they are adapting to the antibiotics which have been unnecessarily taken by the patients, which is causing the different kind of mutations in the gene. So what is the facts about antibiotic use? Is it that we can just create certain awareness programs also? So just because many times we see that most of the programs, they just highlight about the misuse or the information about the resistant. But we should also remember that antibiotics, they are life-saving drugs, and they are only to treat the bacterial infection. So if this message is gone, so many people, they are well educated enough and they know like certain diseases, what they are suffering from, they can be fungal or viral or protozoal. So they should be informed and they should be well educated that this antibiotic is only for bacterial infection, and that some kind of infection that do not require antibiotic at all, and especially that most commonly the statistics shows that antibiotics are most commonly taken for sore throat, so that for any sore throat infection it is not taken. And the survey result, what we found is that people have a myth that whenever there is a green colored mucus, so it is a sign of some infection, and people have been using the antibiotic, and that there are they should be told that it is that these drugs are not safe drug and you have to take it according to the prescription, otherwise they can be at a potential risk. So what is the message is that what are the adverse effect of antibiotic or stopping or misuse or overuse. So we need to just inform, we have to do certain kind of programs or certain kind of this it should be included in the even in the health profession curriculum, so that this message goes across, that there are even the side effects of the antibiotics, and all of us know what are the side effects, and every different antibiotics have got different side effects. Yes, please keep on moving. Yeah, so these side effects, they can be very, very severe also. So the people, they should be aware, because sometimes it should not happen that they think that they are suffering because of their disease condition, but they should, like, once they are very well educated about their about the side effects, the mild or the severe side effect, so they will be able to understand how to properly use the antibiotics according to the prescription given to them. So this is like in one of the survey which was done, we were just very astonished to see that men, like in that which the hospital where the antibiotics, they were very like overused was. So many patients, they just reported that they had some kind of urticaria, or they were suffering from coughing, wheezing, and like many people, they were even having anaphylactic reactions. So in that, when we just somebody shared the survey report, so they found that these were all the allergic reaction to antibiotics, about which people, they were not even aware. They don't know that even these, they can be allergic to certain antibiotic like penicillin or cephalosporin, and it was just taken without prescription, or for the disease condition for which these antibiotics were not needed. So this was alarming statistics which was seen, and for which, like, it was overlooked that it was because of the reason was antibiotics, but it was related that all these problems are happening in the patient because of the condition they are suffering. So this is how many times the health profession, like the people who are dealing with it, so even they just, it has got a masking effect, or such sign and symptoms, they are overlooked, which may be because of antibiotics, but it is taken as because of the disease condition. And especially the other survey when it was done, so these are the different surveys statistics. So other than the allergic reaction, it was found that antibiotics which are used to kill the bacteria, so even it was taken for the fungal infection, and even it was leading to the development of the fungal infection, because it was so much of the it was overused and misused in certain hospitals, and especially it was happening in the developing countries. So like there, as a awareness program, it was like we informed that they cannot be treated for a fungal infection. So why this kind of information is shared here is that, because it is like many, we just think that many people, everyone, they know about it. Many
Excuse me, Prof. Ansu, are you still with us?
can I So I will just it has got hanged, so I will just continue right. So they say that what we need to make people understand is that they are all different drugs for different actions. So they should know that antibiotics, they are antibacterial, they are against the bacteria, whereas if they are taking against the virus, they have to take antiviral drug, there are antiparasitic drugs, and there are antifungal drugs. So how can we avoid antibiotic misuse? So there are ways to help to reduce the risk of developing antibiotic resistant infection. So number one, so we need to take the prescribed antibiotics as per norms. And even if the symptoms subsides, we should not discontinue antibiotic before the completion of the course, and never take antibiotics prescribed to someone else, and take them exactly as the doctor has prescribed. So these are the 4 points. Like if anybody of the participants, they have done any survey programs, or they have gone to the statistics, or they have done the meta analysis of any articles, so you will see that the most of the problem, it goes around these 4 points. So that is that people, they just don't take the antibiotics according to as prescribed to them, and this is the most common problem which is found on meta analysis as well as the surveys done was that people, they discontinue before completion of course. And the very alarming thing which was noticed was that people, they are just asking others, which antibiotic are you taking? I am having cold, I am having sore throat, I am having some stomach problem, which antibiotics you are taking? And they are taking the antibiotics which are prescribed to someone else. So we are here, we as a health profession educator, we are here, and we can help to reduce this antibiotic resistance. So how can we use it? So they say that number one, we have to just do this awareness program, and as well, all of us are here, so this here we are just sharing it among the we are all educators, but these kind of programs, they can be open for the public also, so these infections, they will become non-treatable. And the other thing is, like, antibiotic resistance, it can affect any age, any country, whether poor or whether rich. And they say that it can if you mostly during the COVID-19 days, it was found that these antibiotics which were given for maybe like it was a new disease, so it was overused, but it was a cause of making the symptom worse or the condition of the person worse. And maybe if any research or survey is done, so like it may not be a surprise if we found to see that these antibiotics, they were the reason for the patient to stay in the hospital for a long time, or even may have led to the death of that patient. So if we go to further, so the message which has been given in our awareness programs, in our campaigns, and we can just again go on just spreading this information, is that we should not save antibiotics for later, because this is in many houses you will see that people, they just use some of the antibiotic, they just keep it, and when the similar symptoms appear again, they are using this antibiotic, and even they don't even check the expiry dates, and it has been found that people had been using even the cold antibiotics. And for the flu, like anyone you come across, you will see that this is a myth, that antibiotics, they can cure flu, and most of the people, they are misusing it for flu-like symptoms. And therefore, it is like if we can just educate the people, educate the public about there are alternative to antibiotics also, like we have just had a talk. So there are other herbal medicines, and there are ways where they can just maintain their hygiene, or they can just take some precautions to prevent the infection. So these type of things also may help to prevent the overuse or misuse of antibiotics. And
excuse me, Prof.
And
your time is 5 minutes left. Yeah.
Okay, right. And it was very interesting to see that people, even they were just breaking up and crushing the antibiotic or the pills, and they don't know it can reduce its efficacy. And they don't even know, like there are certain kind of myth, like certain antibiotics they have to be avoided by like if they can be used with certain fruit or fruit juices or alcohol, what time. So many times we see that whenever any program, any seminars are done, so these type of things have to be taught, because these are the factors which are not taken into consideration whenever we are trying to educate the public about the antibiotics and the antibiotics use or misuse, so which is leading to it. So the take home message is that antibiotics, we need to tell the public, we need to inform, we have to spread this information that antibiotics cannot treat the viral infection, especially the conditions like the cold or the flu. And this we have to encourage that, because we all know prevention is better than cure. So just encourage people, and just especially just the these elderly people or the children, and that even the timely immunization and there are so many this infection and the disease control programs are there, where we can just educate people to how the simple steps can prevent the spread of infection and can prevent the antibiotic resistance. So this is the other thing before I just conclude my talk, that if because we had been doing many surveys, many research in the from different aspects. So the other very interesting finding which just came to our notice was that people had been very commonly they were found to be skipping the doses of antibiotics, or they were not taking it at the regular intervals, or they don't know, like in the children or the elderly, that doses of the antibiotic may be different. So this kind of issues were also like it came across to our attention. And I think that this is also very important aspect, because this type of issues are also leading to the antibiotic resistance, and it is also it is also like a matter of concern. And I think that certain programs or certain we don't know like how we can inform the health authorities of the different countries, since it is an international forum. But in certain countries, I think that how the right use of antibiotic should be done, how it should be taken only by the prescribed doctors, what are the like other factors which should be taken into consideration when the antibiotics are prescribed, and like how the complete treatment or the compliance is very, very important. So this is a very important aspect. So as a doctor who are health professional, the message should be prescribe antibiotics only when required. And before prescribing the antibiotics, they should just do the culture done. And the dose, duration and indication of prescribed antibiotic should be well explained to the patient, and the follow-up of each and every patient is very important. I think this is a duty of each one of us as an educator or as a doctor or for the individual. So we have to just give this message across that they have to stop the self-medication. And because if they are just doing it, they are putting their health at risk. And for just like most of the people, like it is, the message should go very strongly that for cold and flu, the antibiotic use is inappropriate. And that all this leftover antibiotics, they should not be used, and they should not use their doses or other kind of information about antibiotics to their family members or to their friends. So to conclude, the conclusion of this talk is that this talk, it was mainly a summary of everything which has already been covered in the various talks which is going on since the morning. So the problem of antibiotics use and misuse and the impact it has had on the health of the people is the lack of knowledge about antibiotic, how it is, like what kind of the infections it has to be used, and where even if it is a viral infection because of low immunity, still it can be used, how it can be used. So all those factors which has been covered in this talk, they were the part of surveys done, they were the part of research project, they were the conclusion, they were the abstract, they were the information taken from the meta-analysis. So it gives an insight that what all is going on in the different countries, in among the public, among the educators, and among the common people, and where all the rectification and the recommendation may help. So this is all about the this about the talk today, and I just want to give thanks to the organizers, and I just want to give my special thanks to Dr. Shirley and Dr. Geeta. And just my message is that these antibiotics, though it is a matter of concern, but it is not that we cannot do anything about it. It is like if everyone join hands together, so that we can just it so uh, the high price which is paid for such type of issues, so it can be stopped. And that is what I want to say as a conclusion of my talk. So thank you so much. So we can say no to the misuse of antibiotics. So the take home message is that it is highly important that we as an educator, we as a health professionals, and we just as a like even it's a duty to the for our community or for our family and the friends, that whatever knowledge we have, we need to spread it so that the effective treatment, accurate diagnosis, it can be done. And this antibiotic resistance, which is becoming a pandemic, it can be stopped. So thank you so much. I'm sorry because of this slides which could not be moved. So maybe like I couldn't share. I just wanted to show you more statistics also, the surveys, the results of our surveys also. So maybe whenever the next time we get an opportunity, I will like to share all the statistics and the research projects reports. So which will give an insight that this pandemic of antibiotic resistance, it has become like a COVID-19 pandemic, which is very silently taking away the life of patient. And if we just can spread the information, we can just take it seriously. So this can be stopped. It is nothing that it has got no remedial measures. So thank you so much. Thank you for listening, and thank you again.
Thank you, Prof. Ansu, for your excellent presentation. Now I want to invite the second speaker, Dr. Velma Herwanto, SPPD, PhD, Finasim FACP, will talk about optimizing antibiotic use in hospital and primary health care. Dr. Velma, the floor is yours.
Thank you, Dr. Donna.
This is the CV from Dr. Velma, current as Fellow of American College of Physicians, Best International Abstract Sepsis Conference, as Fellowship Division of Tropical Medicine and Infectious Diseases, Department of Internal Medicine, Faculty of Medicine, University of Indonesia. Welcome, Dr. Velma.
Yeah, so good afternoon, dear seniors and colleagues. Dr. Shirley, Prof. Getty, Ibu Lalita, nice to have you here. So it's tough for me to be the last speaker today. I'll try my best to keep you up through the next 30 minutes. So yeah, this is my slide. It is an honor for me to talk about optimizing antibiotic use in hospital and primary healthcare setting. So I won't separate my talk into hospital and primary healthcare setting. I'll talk about them all together as a whole. Next slide, please. So antibiotics are the cornerstones of basic and modern medicines. Treatment of infectious disease, as well as modern medical procedures, are all relies on functioning antibiotics. So in infectious diseases, as well as besides infectious disease, we also use antibiotics for as part of cancer treatment, for surgical prophylaxis, and also as part of, say it, organ transplantation procedures. Next slide. So in this slide, I want to show you the timeline of the discovery of different antibiotic classes. The first antibiotic discovered was in 1928, that was penicillin. And then the discoveries was followed by numerous antibiotics which peaked around 1950s years. and the discoveries are slowing down until it reaches 1980 here. So the discovery void here refers to the period where the last antibiotic was introduced in 1987. That was the last antibiotic successfully introduced to the market as successful treatment of antibiotics in clinical use. So it means that we are running out of antibiotics while the resistant pathogens are growing up. That's the reason that we need to study about optimizing antibiotic use, because we need to use antibiotic effectively to prevent the emergence and to treat the resistant pathogen while saving the patient at the same time. Next slide. So talking about optimizing antibiotic use means we need to discuss about rational antibiotic prescribing, antibiotic resistance, and also the practicality of antimicrobial stewardship. Next slide. We're going to talk with rational antibiotic prescribing. So the principles of rational antibiotic prescribing involves the conduct of doing correct diagnosis, whether this is an infection or merely a systemic reaction. Is the infection caused by bacteria or caused by the virus or the parasite? And we need to do to imply it to the correct patient as well. We need to think whether the patient has spatial consideration that needs to be considered when we choose antibiotic for the patient. For example, whether the patient is pregnant or maybe elderly or immunocompromised. And the next thing to be considered is the correct antibiotic for the infection we aim, correct dose regimen, and we also need to watch for adverse events and drug interaction. Adverse events can be in the form of allergic reaction or gastric upset or diarrhea or, for example, nephrotoxicity. Next slide, please. It means the issues in rational antibiotic prescribing must be any problems against the points mentioned in the previous slide. We're going to talk the first issues, which is the indication. So we need to evaluate whether we give antibiotic for the right judgment, or do we give the antibiotic to the patient, for example, it's just because the patient has fever. So one must remember that infection of the many causes of fever, and infection is not merely caused by bacteria, it can also be caused by virus or parasite or fungal infection. Next slide. So these are the 4 strategies of antibiotic therapy. Those include prophylactic, empirical, preemptive, and targeted strategy. So in empirical strategy means that we give the antibiotic to the patients based on the clinical signs and symptoms of infection, and no pathogen identified yet on that stage. Giving the antibiotic for targeted purpose means we give the antibiotic based on the definite proof from histopathology or culture result. And giving the antibiotic for prophylactic purpose means that we give the antibiotic to prevent the infection to happen. It means we give the antibiotic to totally healthy person, for example, for surgical prophylaxis. And the last strategy is the preemptive purpose, which means that we give the antibiotic based on the laboratory test or radiographic signs suggesting infection. We don't have any definite proof or infection, and the patient doesn't have any clinical signs suggesting of infection. Next slide. So it means that when we are going to give an antibiotic to a patient, we need to exactly define what purpose we are aiming to. For example, patients coming to us with fever and productive cough, and on auscultation, you hear rhonchi on bilateral lung. So it means that we give the antibiotic to the patients for empirical purpose for pneumonia. Later, if the patient's coming to us with this sputum culture result, it means we change the antibiotic or adjust the antibiotic based on the culture result. It means it is a targeted purpose of giving antibiotic. The next issues raised in rational antibiotic prescribing is about choosing the correct class of antibiotics, which includes the consideration of the causative pathogen, the host. So we need to consider every point from the host. For example, whether the host has, for example, chronic kidney condition, which means that the antibiotic dose needs to be adjusted.
or whether the patient is pregnant. It means that some antibiotics must be contraindicated in that patient, or whether the patient, for example, has any exposure to antibiotics in the last 3 months, means that the patient might be at risk to be infected by resistant pathogen. And the other thing needs to be considered when choosing the class of antibiotic is the pharmacology and also the cost effectiveness. So cost effectiveness is a great importance in antibiotic prescribing because we all know that we need to choose the most effective antibiotic with the least possible cost when treating patient. Next slides. So there are at least 12 major classes of antibiotics in the market in clinical use. Each different antibiotic covers specific pathogen. Some of the antibiotic covers gram-positive, some covers gram-negative, some covers atypical or anaerobic bacteria. So when we are going to treat the patient, we have to know exactly what bacteria or what pathogen we are aiming to. For example, when we are going to treat patients with urinary tract infection, it means we need to choose antibiotic that covers gram-negative, because most of the causative pathogen in urinary tract infection is gram-negative bacteria. Next slide. How about the spectrum of the antibiotics? So an antibiotic can either have narrow or broad spectrum. Narrow spectrum antibiotics are more specific because it covers only certain group or strains of bacteria. Generally, it is preferred because it has limited effect to commensal or resident bacteria or normal bacteria in our body. While the broad spectrum antibiotic inhibit wider range of bacteria group, and it is frequently used in critically ill patients which are in worse condition, which needs to cover more possibilities of bacteria that infect the patients. Next slides. The next point to be considered when choosing the antibiotic class is the pharmacological profile of the antibiotics. So it covers the discussion of therapeutic concentration on infection site. The easiest example is moxifloxacin. So moxifloxacin doesn't have adequate concentration in urine. Therefore, we don't use moxifloxacin for urinary tract infection. That's the easiest example. And the other things we need to be considered is whether the antibiotic has a profile of concentration-dependent or time-dependent killing, whether the antibiotic have a post-antibiotic effect after the last dose administered, whether the antibiotic has bactericidal or bacteriostatic profile, and whether there is any drug interaction between the antibiotic and the non-antibiotic medication that might hinder the optimum response of the antibiotic. Next slides. So in this slide, I want to show you the comparison between time-dependent and concentration-dependent profile of antibiotics. Here, the time-dependent antibiotic. So in time-dependent antibiotic, we aim to achieve the concentration of the antibiotic above the minimum inhibitory concentration as long as possible. So the longer it stays above the MIC, the more pathogen will be eradicated. So usually we give the antibiotic with the time-dependent profile more than once a day to make the concentration stays above the MIC. So we give it again. The concentration will boost up every time we give another dose of antibiotic. While in concentration-dependent antibiotic, we aim to achieve the higher or the highest concentration possible above the MIC, because the higher the concentration we achieve, the more bacteria will be eradicated here. So usually we give this kind of antibiotic only once per day with the highest concentration possible to kill the bacteria. Knowing this fact will allow us to give the antibiotic with the correct interval. Next slides. The next issues raised in rational antibiotic prescribing is about the regimen, which covers the dose, the route, whether we need to give the antibiotic orally, parenterally, intrathecally, or by inhalation, for example. So generally, we prefer to give the antibiotic orally because we can reduce the risk of bacteremia or phlebitis. We can cut the cost and the hospitalization duration of the patients by giving an antibiotic orally. And we also need to consider the frequency based on the pharmacological profile and the duration. We normally give antibiotic to the patients around 5 to 7 days, except in certain conditions. We are going to talk about the duration further. Next slide. And the last issues in rational antibiotic prescribing is about the monitoring of the antibiotic effectivity. Next slide. So early evaluation response, preferably on the 3rd or 4th day of treatment, is essential to ensure that the patient's receiving suitable treatment and to further determine whether we need to stop, to continue, to change, or to modify the dose or regimen of antibiotic. If the patient's responding well on antibiotic, then there is no necessity to change the antibiotic, even though, for example, the culture result shows resistant pathogen. In contrary, if patient doesn't show any improvement on antibiotic, that we might consider to change or modify the antibiotic regimen. Inadequate response to antibiotic treatment might be due to incorrect diagnosis or therapy, might be due to resistant strain, might be due to secondary infection during hospitalization, who knows, and might also be due to non-compliance of the patient. Next slide. So the big question is how we choose the correct empirical antibiotic then for the patients. So our government has published a national guideline of standard of therapy. It was published in 2021. This guideline suggesting the empirical antibiotics for the most common sources of infection. Next slide. So for example, this is the empirical antibiotic suggested in ear, nose, and throat infection. Amoxicillin and its alternatives are the empirical antibiotics suggested in acute bacterial tonsillitis here. Next slide. And this is suggestion of empirical antibiotic for lower respiratory tract infection or pneumonia. So we can see here that this guideline suggested a combination approach or combination antibiotic for inpatient pneumonia, and they suggest monotherapy of antibiotic for outpatient pneumonia because we know that in outpatient pneumonia we have to cover more possibilities of bacteria in a worse condition of patient. Next slide. So we just finished the rational antibiotic prescribing discussion. We are going to talk about antibiotic resistance, but I won't talk that much for this discussion because I think it has been covered very well by other speakers. So next slide. Next slide, please. Antibiotic resistance is a situation where bacteria develop defenses against the antibiotics used originally designed to kill them. One amongst the etiology of antibiotic resistance is irrational antibiotic prescribing, which leads to resistance, treatment failure, and adverse events from using antibiotic. Next slide. WHO has published antibiotic resistant priority pathogen list in 2024. So basically, this is a catalog of 12 families of bacteria that pose the greatest threat to human health. This list highlights, in particular, gram-negative bacteria that are resistant to multiple antibiotics. Those include Acinetobacter, Pseudomonas, and Enterobacteria that can cause a severe or even deadly infection, for example, bloodstream infection and pneumonia. So to optimize the antibiotic use means that we need to be able to effectively treat this kind of bacteria while preventing this kind of bacteria to develop in the future. Next slide. And the last discussion is about how to apply antimicrobial stewardship after we learn all the rational antibiotic prescribing and antibiotic resistance. Next slide. Antimicrobial stewardship is a coordinated program that promotes the appropriate use of antimicrobials, improves patient outcomes, reduces microbial resistances, and decreases the spread of infections caused by multi-drug resistant organisms. Next slide. To apply or practically apply antimicrobial stewardship, WHO has made AWARE classification here, which has been updated in 2023. So this AWARE classification grouped the antibiotics into 3 groups according to the potency to induce resistance and according to the priority of antibiotics those who require monitoring. The list of the antibiotic include the most common antibiotic used for 21 diagnoses of infection. We can access the list of the antibiotic here from this source. So the antibiotics are grouped into access group if it is the empiric first or second choice for the treatment of the most common infection. It is grouped into watch if the antibiotic have higher toxicity concerns or have higher resistance potential. And reserve group include the new treatment options that are reserved for complex infection. Next slide. I'm sorry, this is too small, but yeah, we can access it online. So this is the complete list of the antibiotic from AWARE classification. In a quick look, we can see here the antibiotic in access group are mostly used in outpatient clinic and in stable hospitalized patients, while antibiotic in the watch group are mostly used in hospitalized patients, and antibiotic in the reserve group are mostly used in critically ill patients or in multi-drug resistant cases. So generally, antibiotics in access group are more often available in oral formulations, like nearly 60% of them. And the percentages are lower in the other 2 groups, around 40% of oral formulation in watch and 10% in the reserve group. Next slide. So this is one example on how to choose antibiotics using AWARE classification. So say we have a patient coming with sore throat or pharyngitis, like Prof. Anshu said. So when patient coming to us with pharyngitis, the treatment that we give to the patient is anything but antibiotic, because we all know that pharyngitis are most commonly caused by viral etiologies. The symptoms will be improved within days. But later, if we decide to give antibiotic to the patients, then the first choice will go to amoxicillin from access group, and the second choice will go to clarithromycin from watch group. Because, for example, the patient say it have allergy to amoxicillin or are contraindicated to amoxicillin. Next slide. So we have learned all the things to be considered to optimize antibiotic use. So the main target we aim to ultimately optimize the antibiotics is the 3 things. First one is to reduce the use of antibiotic. The second one is to reduce the risk of emergence of bacterial resistance. And the last one is to facilitate clinical reasoning and improve prescribing environment, at least in our workplace. Reducing the use of antibiotics, in particular broad-spectrum antibiotics, include the act to rapidly do microbiological diagnostics, implement inflammation markers-guided therapies, and shorten the duration of antibiotic treatment. While reducing the risk of emergence of bacterial resistance include the act to choose the lowest class of antibiotic with the least potential for reducing resistance, and choosing the right dose and route according to the pharmacological profile. Next slide. Let's talk a bit further about the rapid microbiological diagnostics. So long turnaround times of conventional testing, that is culture and sensitivity tests, will hinder withholding or rapid stopping of unnecessary antibiotics and will also hinder rapid escalation or de-escalation of antibiotics. This might delay to give the optimum treatment for the causative pathogen. So rapid methods for identification of bacteria and antimicrobial susceptibility testing using, say, PCR or MALDI-TOF will provide results within minutes to hours, thereby bypassing time demanded for culture results. And this will allow for, thank you. This will also allow for antibiotic adjustment in 71% of patients, including the discontinuation and the escalation of antibiotic, resulting in average saving of 6 antibiotic days per patient. So practicing the rapid microbiological diagnostic will cut your treatment time of antibiotics 6 days lesser than normal. Next slide, please. Inflammation marker-guided therapies is particularly true for respiratory infection, as it is the most indications for antibiotic treatment, but are mostly viral etiologies. Most commonly used and available biomarkers are CRP, which is synthesized in response to interleukin-6, which is a pro-inflammatory cytokine, and also procalcitonin, which expressions is upregulated in response to bacterial infection and downregulated in response to viral infection. So some guidelines recommend interpreting CRP value as below in suggestive pneumonia patient. If the CRP is less than 20, with symptoms last more than 24 hours, makes the presence of pneumonia unlikely. Therefore, we don't offer antibiotic in this kind of cases. While if the CRP level is more than 100, then the diagnosis of pneumonia likely. Therefore, we can offer empirical antibiotic therapy in this kind of cases. Procalcitonin is also effective in discriminating bacterial from viral etiologies. Next slide. The standard duration of antibiotic therapy for most bacterial infection is mostly not evidence-based and is frequently unnecessarily long. A simple and safe strategy to reduce antibiotic use is therefore the reduction in the length of standard antimicrobial regimens. So some randomized controlled trial comparing traditional versus short course of antibiotic showed comparable efficacy between longer and shorter treatment of antibiotic with fewer adverse effects found in shorter course of antibiotic. Here, for example, in community-acquired pneumonia, to give the antibiotic for 3 to 5 days are comparable to 7 to 10 days. Next slide. So this is one of the strategy to shorter the antibiotic treatment using procalcitonin-guided therapy. So for example, we have an ICU patient and we are in doubt whether the patient's having bacterial infection or not. So one of the strategy is measuring procalcitonin level or PCT level. If the PCT level is more than 0.5, then we might consider the patient's having bacterial infection, thereby need antibiotic therapy. I say consider because we all know that a lot of things to be considered to say someone having bacterial infection not merely relies on procalcitonin level. And later on follow-up, we can measure the procalcitonin every 24 or 48 hours. In the follow-up, if the procalcitonin level decrease at least 80% from the peak concentration, or the concentration drops into less than 0.5, then we might consider stopping the antibiotics. But if the PCT level decreases less than 80%, or even worse, elevated, then we might consider to continue or changing the antibiotic regimen. Next slide. I think this is second to my last slide. So this figure depicts on how therapeutic strategies should be adapted to the available information and goals, which indeed changing along the infectious disease courses. So say we have a patient with suspected infection, say it pneumonia. If the patient's coming to us, then we will dig in for more clinical information and local epidemiology data such as the endemic infection or the local resistance data from the patients coming from. And then before we give appropriate empirical treatment to the patients, then we need to obtain samples for microbiology and laboratory examination. The goals are simple: for the patient survival and also to improve the symptoms of the patients. And the long-term goal are to avoid resistance and to minimize toxicity from antibiotic using. Later, after the microbiology and the laboratory results come out, then we can de-escalate or switch the antibiotic and maintain the course of the therapy until it is finished, guided by the clinical improvement and also guided by the laboratory examination from the patients. Next slide. So to conclude, to implement rational antibiotic prescribing means that we need to be able to apply correct diagnosis, correct patients, type, dose, and duration of antibiotic, and also consider the cost effectiveness of the antibiotic. We need to monitor the efficacy, adverse events, and drug interactions when giving antibiotic therapy. And to choose the correct empirical antibiotic therapy, we can use the national guideline, which is the PNPK, and also the local antibiotic susceptibility pattern. The aim of antibiotic therapy is simply to eradicate infection and prevent the emergence of resistant pathogen. And to imply antimicrobial stewardship, we can use the AWARE classification published by WHO. Thank you.
Thank you. Thank you, Dr. Velma, for your insightful presentation. Okay, we go through the Q&A session. Please go to the front. I want to open the Q&A session for the audience first. Is there someone want to give a question? Anyone? Okay. Oh yeah. Mention name.
Selamat siang dokter, perkenalkan saya Billy Octavian. Mohon izin bertanya dokter, tadi dikatakan bahwa dalam pengobatan antibiotik itu memerlukan sekitar 5-7 hari. Dan 3-4 hari pertamanya itu kita akan melakukan evaluasi, either kita ganti atau kita tambah pengobatannya atau kita adjust dosisnya. Itu sebenarnya kita lihat dari apa sih dok, kalau misalnya pasien ini kita perlu untuk ganti antibiotiknya atau kita tambahkan. Terus untuk satu lagi dokter mengenai dosis, kalau misalnya kita ternyata kasih dosisnya tidak cukup, terus kita anggap ini pengobatannya tidak berhasil, itu mending kita tambahkan dosisnya atau kita ganti saja obatnya dokter. Terima kasih dok.
Should I answer in English or in Bahasa? It's a tricky question though. So yeah, since there is Prof Gita and we are talk Bahasa. Thank you for your question in Bahasa Indonesia. It helps me a lot. Jadi untuk pertanyaan pertama, sepertinya pertanyaan pertama dan kedua bisa saya jawab jadi satu. Jadi begini, pada saat kita memberikan antibiotik pada pasien, tentunya kita mengharapkan antibiotik itu efektif untuk membunuh patogen dengan memperhatikan segala kondisi kesehatan pasien, apakah dia ada background komorbiditas misalnya. Dan respon antibiotik itu pada setiap pasien berbeda-beda. Nggak artinya dengan patogen yang sama antibiotik bekerja pada saya, bekerja pada kamu, tiap pasien beda-beda. Maka dari itu, daripada kita pukul rata langsung memberikan 5-7 hari antibiotik, maka dari awal 3 hari pertama respon antibiotik itu sudah bisa harus terlihat. Jadi tidak ada pada saat kita memberikan antibiotik 3 hari belum ada efek klinis, lantas kita bilang, oh nanti dulu tunggu hari kelima mungkin ada efek. Tidak. Antibiotik bisa kita putuskan bekerja atau tidak secara klinis maupun laboratorium pada hari ketiga. Makanya itu alasan kita bisa evaluasi di hari tersebut. Kalau tidak cocok, kita lihat masalahnya ada di mana. Bisa patogennya tidak cocok, bisa dosisnya tidak tepat, bisa pemberiannya tidak tepat. Atau ternyata sumber infeksinya tidak sesuai di awal. Kita pikir sumber infeksinya pneumonia. Ternyata pneumonia tidak parah, yang parah infeksi saluran kencing. Artinya kan antibiotik berbeda pilihannya. Nah, itu alasan kita mengevaluasi di hari ketiga. Evaluasinya bisa dari apa? Kalau pasien kondisinya buruk, kita bisa evaluasi dari tanda vital. Dari tensinya, dari nadinya, dari suhunya, dari respiratory rate-nya. Lalu kita bisa bantu juga dengan laboratorium sederhana, misalnya dengan leukosit, kemudian juga dengan CRP atau prokalsitonin. Ini saya menyebutkan sesuatu barang mahal yang belum tentu di semua tempat pekerjaan kita ada, tapi saya menyebutkan ideal karena kan ini ranah pendidikan ya. Lalu apabila ternyata menunjukkan perbaikan, lanjut, selesaikan. Kalau nggak selesai atau hasilnya nggak baik, ya cepat ganti di hari ketiga tersebut. Gitu. Kadang-kadang ada juga alasan bahwa kalau kita melakukan kultur kan keluar di hari kelima ya, pada umumnya tuh, sputum hari kelima, urin hari ketiga. Nah, kalau kita mau lanjut, dok ini jelek, tapi saya nggak tahu mau ganti kemana, saya tunggu hasil kultur, boleh silakan. Setelah ada hasil kultur, buru-buru tuker. Gitu. Jadi kalau kita lihat di klinik, yang sering sama-sama klinisi salah, saya juga salah adalah kadang kita berharap terlalu baik, tunggu dulu mungkin bekerja, nggak ada. Sekarang masanya kalau nggak cocok, tuker segera. Antibiotik kan sekarang reserve-nya banyak, bukan cuma 1-2 macam. Dulu zaman saya sekolah hanya ada yang paling tinggi, katakanlah ceftriaxone. Sekarang kita bisa naik kemana aja kalau memang diperlukan. Demikian, menjawab pertanyaan tidak kira-kira?
Any question? Ada yang mau bertanya lagi? Boleh dalam bahasa Indonesia. Ada lagi mungkin yang udah koas pengalaman sehari-hari, Dek? Oke, kalau tidak ada saya lanjut ke pertanyaan dari Zoom. From Dr. Rudi Susanto. From the presentation, 3 months will be exposed to possibility of antibiotic resistance. So after 3 months will be decreased possibility of resistance. Maybe this is a question for Prof. Ansu ya. Prof. Ansu still with us? Excuse me? Or already left Zoom? Atau mungkin bisa dijawab dulu sama Dr. Velma. Yeah.
Yeah, I think I mentioned it in my presentation about the host condition.
Yes.
Yeah, so we need to pay attention. So when we need to choose empirical antibiotic for the patient, I'm talking about empirical antibiotic because when choosing empirical antibiotic, we need to think on what's the source of infection and what's the possibility of the antibiotics we need to give. Targeted therapy or definitive therapy is easy. I mean, not easy. We just need to look at the culture result and we choose the antibiotic based on the culture result. But using or choosing the empirical antibiotics is a little bit tricky. So we need to consider, one of the consideration is whether the patient has been exposure to antibiotic treatment in the last 3 months. Because when a patient has been treated with the antibiotics, with a certain antibiotics in the last 3 months, means that the patient, how to say it? So the certain pathogen has been killed by the certain antibiotic. It means that the the pathogen that is left not killed by the past antibiotic must be the pathogen that is infecting the patient at the moment. Do you get it? So when the patient has been treated by certain antibiotics in the last 3 months, means that the antibiotic has successfully killed the last pathogen in the last 3 months. It means that the patient may be infected by another pathogen that is not covered by the last antibiotics in the last 3 months. So we have to think that the patients must be infected by other bacteria that is separated or different entities from the last infection that has been treated. That's yeah, I think that should answer. I think.
Yes, thank you, Dr. Velma. The last question from Gunawan. How can we know the length of antibiotic treatment? Should we continue with oral antibiotic after finishing the IV antibiotic for how long? Yes, to Dr. Velma.
So I think I get the message from the question. In the past 10 years, we have a conventional strategy of discharging the patient with oral antibiotics. So if we give antibiotics during hospitalization, it's a must, quote by quote, to send the patient home with oral antibiotics. Is anyone doing it here? Are you dare enough to send the patient home without antibiotics when the patient is hospitalized with antibiotic therapy? No? No from this side? Okay. So before we send someone home, there is not a must to send someone with oral antibiotic home. If the infection finished in the hospital, then we can send the patient home without antibiotic. How do we know the patient has been cured by the antibiotic? Like the one I mentioned before, from the clinical impression and also from the laboratory result. If the patient is cured and we have treated the patient, say it around 7 days with antibiotic, then we can send the patient home without antibiotics. But if the patient improved, say it on the 3rd day, and we have to give the antibiotic to the patient, say it for 7 days normally, then the rest, the 4 days, you can send the patient home with oral preparation for another 4 days. Yes. Do you get it? Okay, yeah.
Okay, I think that's all for the question. Maybe there is another question from the audience. Okay, if there is no, this is the end of the session. Thank you, Dr. Velma, thank you for all attention. I giving back to the Master of Ceremony.
Thank you, Dr. Donna. Thank you, Dr. Velma. Thank you to our doctors and moderator. And now, symbolic awarding of certificates to our speaker, Professor Dr. Anshu Agarwal. Maybe we can show it through the Zoom first before we go in here. Oh, already left the Zoom, okay. So we continued by giving a certificate to Dr. Velma Herwanto, SPPD, PhD, Finasim FHCP, Dr. Donna Tilamano, SPMK, that will be given by Dr. Shirley Gunawan, SPFK. To Dr. Velma Herwanto, Dr. Donna Tilamano, and Dr. Shirley Gunawan, please occupy the designated place. With the end of the third session, it also marks the end of today's seminar. I hope what we've got earlier could be useful for further scientific development and medical practice. Thank you to all the speakers, the committee, and all the participants, both offline and online. We'll see you at the next seminar of the Medical Faculty of Universitas Tarumanagara. I'm Nikita Tan, signing off as your Master of Ceremony. Thank you.